having network, some are having network issues to join, and so just we'll admit other people into class, but we need to start the class proper because we can no longer wait. Time is really going. So like I said much earlier, that the journey of in the journey of AI, in the journey of you want to be an AI specialist, you want to go into data analysis, you want to go into data sciences, AI in general, anything related to AI, the use of statistics or the study of statistics, as it were, is very, very important. Very, very, very important. So I want every one of us to take this class very seriously. Very seriously. You never can tell when you'll be in need of it. So it is very important. And we'll be having a practical class today. Practical class, it is not just about learning the statistics. It is also about knowing how to use some of the tools to do these things on Microsoft Excel, right? So it is going to be a practical class. And as we progress in the class, I want every one of us to be attentive to we should have our jotting materials already beside us, and then we should also be ready to take the practical sessions using our laptops to with also our Excel opened, because we're going to be doing it together. So without any further ado and without wasting much of our time, I want to introduce to us the lecturer for the day. And the person who is going to be training us for today is none other than Okobong Ebedoro. Can we all welcome Okobong Ebedoro in the chat room? Wherever you are, welcome the trainer for today. Can we welcome the trainer for today? Over to you, Okobong.
Oh, okay. Thank you very much. Good morning, everybody. From my end, I want to apologize for coming a little bit late. I don't like going late, but today some events were beyond my control, so it took me a longer time than I expected to reach where I can go online. Okay, I am. My name is Ukobong Ebedro, like he has mentioned. So we are taking today introduction to statistics. Like he has said earlier about the applications of statistics in so many areas of life. And nowadays we've heard about this trending field, data analytics and the data science field, which so many individuals have expressed interest to go into it. So you can't go into it without understanding what data is and the theories and principles behind so many things that computer and packages can help you do. So what we will do today is to introduce statistics and also talk about those things that you might see if you have interest in data science, those things that you might see, and maybe you are using a computer and packages that can help you have results. So if you know the background and theory behind it, you appreciate it more. And one thing about analysis is that after analyzing, you have results. Yes, the system, the computer will bring a result. But who would interpret the result for you? Nobody. The computer cannot interpret. The computer will only analyze and give you the numbers based on which your own understanding in the concepts will now help you to tell the story about what the screen has shown you. So let's start with statistics. Okay, statistics is something, a word that we have been hearing about. Yes, I think in daily basis, if you listen to news, television news, broadcasting, they will say statistics say, statistics say, statistics say. So statistics is a common word that in every field, in every area of life, it has been used to. So what is statistics? Okay, let me just start from the ordinary meaning of statistics. Statistics is just numbers. values. Yes, for example, if you are someone that watches football match, at the end of maybe some half, even as the match progresses, you will see analysts. They will display on the screen what has gone on in the match. So someone like me, even if I don't watch the match, when I come back and look at statistics, I will just understand how the entire match was. So statistics is so much important to me personally, because I know even if I was not viewing the match physically, once I come back and look at statistics, I'll be laughing. Let's say from how I look, statistics favor the other side, and meanwhile the opponent won. So we'll be like, what is happening? So statistics is something that's been used in so many fields. For example, like football match, I said you will see a number of corners. This side had 15, the other side had 10. Number of fouls. So those numbers that are displayed are also statistics. So statistics may mean numerical value, numbers. Okay. However, what we want to look at deeply today is the other aspect of statistics, which is a field of study which encompasses the entire other statistics you've been hearing about. Okay. All right. So what is statistics? As a field of study, is just a science that concerns with what? Collection, presentation, and analysis of data, and how those analyses is used to make conclusion. Is a science that deals with what? A scientific approach of collection, presentation, and analysis of data, and how the result of the analysis is used to make conclusion or to make decision. So in essence, we have two broad categories or divisions of data, of statistics. The first part is what we call descriptive, and the other part is what we call inferential. The descriptive has to do with the summary, the numerical summaries of the entire bogus information in terms of charts, in terms of values that can speak about the entire data you see in a brief way. Okay? I repeat that the what we call the descriptive statistics is what? Is the approaches you use to summarize the entire data, maybe in graphics, like in charts and pictures, and also in the summaries, like the numerical summaries, like mean, median, and mode. So all those things you'll be hearing about, they belong to a class of statistics known as descriptive statistics. Another part is what we call the inferential statistics. This particular aspect of statistics deals with the estimation and making inferences about a larger group from values that you obtain from a fraction. What? Don't disturb me today. I'm doing something here. We'll talk about it. So in the aspect of inferential statistics, what we do is, because we understand that a larger population has so many values to offer, has so many data to offer, but we know that trying to obtain the information or the data from the entire population may be so expensive or non-practicable. We rely on a fraction of the population to obtain some information. So the information you analyze from that fraction can be used to generalize the result to the entire population. So in the aspect that enable us to do this, what we call the inferential statistics. You estimate, you forecast, you project under this category of statistics. All right, okay. Now, why do we study statistics? Why do we study statistics? Because in some aspect, I think it's recently that the issue of studying statistics has become well little. We were very scanty in statistics class, unlike the engineering field, medical field, and the rest. So we were really scanty. But nowadays, I've been hearing about the use of the word statistics in so many ways, much more than what I heard about that time. So now it's becoming a popular field. Now the question is, Even if you are someone that do not want to be in statistics field, even if you are someone that is scared of calculation, because I think what pursue most of individuals from the area of statistics is the calculation part. So if you are someone that is afraid of mathematics, what I would say now is, okay, why do we study statistics? This is the question now. Why are we interested in this area of study, even though we don't want to be in their field? Why are we so interested in this area? Okay. The reason is that the knowledge of statistics is needed in every field, in almost every field. And that is why one statistician said that time, I mean, John Tukey said, as a statistician, you can eat from anybody's backyard. I think if you check John Tukey message like that. So if you're in statistics field, you can gain from every other field, medical field, engineering field, yes. Yes, I think at this stage, I used to have some persons, they will say, you want to analyze this data now. How can we do it? So in that case, in their own backyard, as engineers, you can also go through that area to enjoy some stipends based on what you offer to them, like analysis of data and maybe collecting data from them, okay? So that's by the way. So one of the reasons, like we are interested in statistics, is what I've just said, that the area is useful in almost every aspect of discipline. That is why in every discipline, you will see at least they will do 1 or 2 statistics courses. So it is expected that these courses, when they want to practice their field, they will apply the science. Yes, because data is useful everywhere. So in particular, I want to talk about how this is used in areas such as the government, such as in agriculture, such as in business and economics, and such as in biological science. So please go to next page. Let's talk about those areas which we need the idea of statistics. Next slide. Okay. In government, let me talk about the statistics in government. I think one area that is, I don't know, is someone hearing me now? Let it not be that I'm speaking for to myself alone. Please, if you are listening to me now, just type go on. If you are listening to me, just type go on. Please, I want to see in the chat section, go on before I move on. I don't want to talk to myself alone. Okay, all right. Okay, we move. I have seen a sign. We move. Now, let me start with government. Statistics in government. Yeah, I mean government of any country, Nigeria included, any country. So, I think one of the area that consumes statistics most is government. The reason is that they have a lot of duty and a lot of individuals to take care of. And in that case, being able to handle problems in the entire population which they are taking care of, they need data. They need data. And this data helps them to make decisions in government. For example, now, in terms of population analysis, a country has so much of populations in their disposal to take care of now. Just imagine someone at the center, Abuja, trying to make decisions that affects people in my village. The question is, how does he even understand how many individuals are in my village? And how does he even understand what problem you are facing? You see? Now, in this regard, the person needs what? Data to understand the section of that population and what they need. Now, even if you have data at your disposal now, how do you make use of it without proper analysis? And how do you analyze data properly without using statistical techniques suitable for the analysis? You see? So government is one of the base consumption or one of the major consumption of statistics because of the critical role they play in human life. Okay, let me mention some advanced countries that I see how they use statistics and it play well for them. Somewhere like, let's say a country like in the UK, whenever an individual is born in that particular country, now they have recorded the person's gender, the person's, and in that case, they have started to make plan about the person, even if the person is still young. So what has enabled them to make plan for an individual at somewhere which they have not seen physically is statistics. They follow statistics so much. Okay? So in terms of health, how do they know the health, how do they know the specific area of health that a region, a part of the region needs? Remember, let's say in a country as a whole like Nigeria that has so many cultures and so many languages and the rest, problems of human are different. Yes. So let's say you want to budget about health in general. You cannot just budget about health in general for the entire population without categorizing the specific needs of the health for some region. How would they understand the health need of a specific region? Let me come for example now. Let's say this kind of health threat like HIV, very good HIV now. There are some states that are threatened by the infection or by the virus than other states. So if you want to make plan, you need to make a heavier plan for those that are being threatened more than other areas. So what will even enable you to understand which state is having more of a threat without a kind of having a clue of statistics how this thing affects them. So government is one of the area that consumes statistics or that use statistics most. Another area is business economics. Business economics. Yes. Some of us here would delve into business. I do tell my students that if you are a business person, you even need statistics more personally than others. Why? Because you cannot set up a business blindly nowadays. That is everywhere. And what helps some organization to have a higher hand than others is what? How they manage the statistics. How they manage. For example, now, let's say in example like market research. Very good. If you are someone that wants to start business, you need an idea about the population to which your business wants to center. So what will happen in this case? You need a market research. Yeah, you cannot just sit down at the comfort of your home and think that you understand what is going on in that section of the population. No, you have to delve into the field to understand. Even if you want to go there personally or want to pay someone, yes, it has to be that the information has been drawn from this section concerning how the product will be sold or how people will be appreciated in that area before you open your business. And what is the field that enables these things to get done easily is what? Statistics. Statistics. You need to go there. You need to sample individuals you want to obtain information from. You need to obtain information. You need to analyze information. And those things are based on the principle and theories of statistics. For example, like sampling. Sampling is a branch of statistics that is able to do what? To draw information from a section of the population. What about estimation? Estimation is what? A section of a statistic that enables you to do what? To project what is uncertain. You project, you estimate, and think about how it will happen. Let me tell you, people that gain more about events that occur are those ones that were able to estimate or that were able to project what will happen. For instance, let me talk about when President Tinubu came into power and stopped the issue of subsidy, fuel subsidy now. And in the next second, the petrol price was skyrocketing. So what happened? There were individuals that were able to capture that once this man entered, fuel price will change immediately. And they were able to stock their petrol in the petrol station. I am telling you, they cash out bountifully within that short period of time. Now the question is, how were they able to even know that the man would do a thing like that? They were able to project, to estimate that this thing will happen, and it play well for them. So those that gain more, before you even now understand how, it takes you by surprise if you did not do that. So those that were taken by surprise were even losing. But those that were able to project, to forecast, to estimate, they were getting from that. So as a business person, you have to do what? Get the knowledge. Even if you are not, you don't want to be embedded in the statistics field, have at least a clue of how to use statistics to make some decisions. Even economics. even economics, something like consumption, expenditure, investment are done statistically. Those that employ the service of statistics in their investment, they enjoy profit. Why? They will invest with informed decision. They will invest with evidence-based decision. When they say statistics says yes, they work with what statistics says. Okay? Even in biological science is also another aspect. Those in agriculture will know what I'm talking about now. They try to twist their experimental designs to check which mixture of feed would yield more in the agriculture or in their farm. So that is also used today in terms of biological science. Something like when they want to bring out another product mix, something like another fertilizer, they have to go into a study, a design that will enable them to check and test which product will yield more in the yield of which fertilizer, which feed will yield more in the life of their farm animals or farm plants. Okay. All right, please. Also have in physical science. You know, in physical science, we understand that physical science deals also with quantities, with mathematical aspects. So you hear about the theories of a kind of something like precision, something like accuracy. It's a common term in physical science, and these are the theories that has been borrowed from statistics. How can you estimate something with a high level of accuracy? How are we sure that as we want to go on, we will not have so much of mistakes? Okay. So in the area of physical science, I think it's also used something like sampling, which enables scientists or those in physical science aspect to draw some samples. Let's say it's something like medical science. Yeah, you hear about blood sample. What is blood sample? What is sample, by the way? What is sampling, by the way? So when we hear about blood sample, this sample we're talking about is something that you capture from an entire population. Now, the thing is, if you sample wrongly, you will end up having wrong information. For example, let me talk about a disease in human body that a doctor may want to test using blood sample. So some disease cluster in a particular aspect of the body. That is it. So it's not just wherever you bring blood, you will detect that. No, some you may have false information. So if you are dealing with such disease or such infection that cluster around a specific section of your body, you need to understand which sampling technique or which sampling scheme you need to use. Okay? I mean that from the start, you need to even understand the meaning of sampling first. And what will enable you to understand this is what? Statistics. So those are a few of the disciplines you have to take now concerning why you should study statistics and how statistics is being consumed in so many areas of life. Please move on. Let's go to next area. Okay, now we want to talk about the types of and source of data now. First of all, let me explain. Let me just ask, what is data? What is data? Because it seems I forgot to mention that. Because if you want to explain or define statistics now, you explain after talking analysis, presentation, and here of data, meaning that data is indispensable in terms of statistics. With data, we don't even have statistics. Yes, because all our analysis, all our estimation centers on data. Now, what is data? Data is just an information. Let me just say, stop there. Data is information. It can be in terms of numerical information or non-numerical information. So any information you obtain is what? Data. Raw facts is data. I'm not talking about manufacturing information. I mean information that is gotten reliably. It's the raw facts. And that is what we call data. So in the aspect of data, the type and the source of data is very important. Having knowledge on the type and source of data and how you are going to obtain is very important. The reason being that a wrong information you obtain can end up destroying all things you are planning to do. A wrong information can throw you, can mislead you. So the aspect of collecting data is very important. And this started what? Knowing the source of data, knowing the type of data which you have to use in your own analysis, in your own projection. Okay, so if you have two types of data and as well two sources, because the sources depend on the type. So the first type of data you have is what we call the primary data. The second is what we call the secondary. Okay, the second is what we call the secondary data. Primary data is what? The first-hand information you obtain. Those ones you obtain first-hand. It wasn't being used before somewhere, and it wasn't kept before somewhere. You are the one that what? Obtain that information. You call that what? Primary data. So any source you obtain under that primary data is what we call what? Primary source of data. So how do you obtain first-hand information? So the source are what? Personal interview. Questionnaire can also be used, and personal observations. So those are the major sources. And what are the advantages of using? Okay, let me come. What is personal interview? Let's say you just go around to talk to your customers or prospective customers on the street. How do you think you can? Okay, are you do you like a product like this? How many times do you use a product like this? So they keep responding. As you are talking to them now, is what you are interviewing them, and that information obtained is what? First hand. And what is the name of that data now? Is primary data. Okay, so what are the advantages of using primary data? Okay, the first advantage is that it's very, very reliable. Why is it reliable? It's because if you are the one that has a concern about what you want to find out and you are involved in data collection process, you will be very careful about the nature of information you obtain. That makes it very reliable and very clear because you understand the extent of the. Okay? Yes, because you are involved, and because you know the extent of having data, you want the thing to be detailed enough so that your analysis would be so exact and accurate. Okay? And again, you have the confidence of the data you collected. You understand? Primary data is what you are very confident about data collection. All the secondary data that has been used somewhere, you just go and extract some information. So you were not the one that collected information. You will be doubting. Is it data? Is it data true? Was it just concocted? You don't understand. So in that case, if you are using secondary data, you are at risk about using something that was not true. Okay, so the advantage of using primary data is also that the investigator is what so confident that the data he collects is true and is from the representative population. Okay, and also the problem involved in the data. The problem involved in data analysis would be integrated in the data collection process. So the investigator that is collecting data would integrate the idea of exact problem that he wants to solve in the data collection process. Okay, and finally, a report from such analysis of data is always very comprehensive. Okay, so those are the advantages. And what are the disadvantages? The first thing is that it is time consuming compared to primary data. It is time consuming. Yes, sometimes before you even finish collecting information, depending on how large the sample is, it might take you days. It might take you days or even months. So in that case, it takes time. And also it's very expensive. You need to pay the cost of designing the questionnaire, the cost of traveling where you want to start your business, the cost of help you to join you in collecting this, because sometimes you may not be able to even do it personally. You need to employ staff. Another advantage is that it needs qualified personnel. So you do not just pick someone from the street and expect him to give you data you want. The manpower has to be qualified. So that's one of the disadvantages. You need to spend on the qualified personnel that will help you collect the information. Okay, Now, let's look at what secondary data is. I think I've explained it before. Secondary data is what? A data that you collect which was already being used by someone else, or which was collected for a different purpose. Even if it's not being used, you are collected for a different purpose, and you just go in there and get information. Those places, those sort of such data are what? Let's say publications, literature reviews, some institutions like hospitals. I can remember back then when I did my own analysis in my first degree. I used secondary data and I collected from hospital. So those are the sources of secondary data. Something like I said, publications from research centers, something like a National Bureau of Statistics. Yes, they are secondary source, and it's also from the internet. From the internet, I think I have used some data before for analysis that someone sent me. And that data was obtained from a website that belongs to the US. So the data that I used was data that is used in the US. So their ministry has a where they stock data. So whenever you want to do analysis, and your analysis concern that, they have a way of opening up so that if you want to use that data, you can go and collect data and use. So those are also secondary source. Why? Because it's not first hand, it was collected already from somebody. So the process the person went through in collecting this, I never knew. So there was not no expensive anyway, just entered online and download and use the information. So imagine how small the expenses you will face if you are using secondary data. However, the reliability is being questioned because you never knew whether the person took the information and put the for information sake. Okay. All right. I want to give this exercise, which I even know that some of you can understand now. That you should state the advantages and the disadvantages. Think about that. What are the advantages and disadvantages of using secondary source of data? Okay. All right, we now move to something else. I believe you are listening. Please, if you are listening, right here, go ahead or continue, please. I don't want to speak myself alone. Audience, please, I need in the chat room, continue. Okay, all right, we are going. Okay, the next thing we want to look at now is data editing. And after understanding data collection process, and after understanding how you get your data, yes, because even as we speak about some defects you may encounter, some deficiency you may encounter in secondary data, we are not ruling out the fact that secondary data can help. There are some things you want to find out, and the case is you must use secondary data. If you want to try to use primary data, you may spend even more than what you have. So both primary and secondary are useful and they are so important. But at the end, after having this information, what do you do next? You go into what? Data editing process. What is data editing? Data editing is what? Checking your data, reviewing your data to remove some irregularities, just to increase the accuracy of the data set and to make it useful for whatever analysis you want to use it for. For example, now, some data may contain empty cells. Maybe you have a data that you collect from somebody, and when you open in your Excel, you see that some cells are empty. There were no responses to such data. So what will enable you to fix all those things is what? Through data editing. So in data editing, you fix up some irregularities, you fix up some repetitions, you fix up some non-responses. So as to make the data what? Reliable. So as to make it look like, make it presentable and useful for your own analysis. Sit down, please. Thank you.
Are you still there? Seems you're not speaking again. So this thing is Wi-Fi. Please, I'm on call.
Okay, I'm sorry about the break. We will continue very shortly. Okay, please let's continue. So the reason you go into editing process is to do what? To filter out some excesses or some shortfall of the data. Excess is something like the spikes. For example, now you are obtaining information about age of individual. Certainly, you see 200 or 300 in age column. You may be asking, how possible is that you have age of individual 300, 400? That's it. So that's why we go into what? Data editing, to filter out those things that are not needed in the data, to filter out those things that will be like spikes, and to fill up those non-respondents. Okay, after that, we look at the source of errors in data collection. Source of error, please, let's go to source of error, please. Okay, data collection process is, I think, a process that you may encounter some error, and a process that may lead to some errors in your data set now. So who are those individuals that can cause some errors in your data set? One of those things is the failure to identify the target population. The what we call the target population. For example, now, if what you want to, your analysis concerns children of age 5, and you make an error, commit an error of going through a population of age, let's say age 6 to 7, 8. In that case, your data set has some question mark, because the idea you have there is different from the idea you wanted. Okay. It can also be from questionnaire problem. You design questionnaire wrongly. Questionnaire has a format. It has some tips you need to have within you when designing them, so that when you want to give the respondent, they will not give you something that is fake. For example, now there are some sensitive information you don't need to put in your questionnaire. Okay, yeah. So questionnaire design is a process that can impute error in your own data set. Unknowingly, you may think you have collected a reliable data, not knowing that what you have, there are some errors. It may also be from respondent bias. An individual you give questionnaire, because of the this advantage or the risk involved in obtaining a kind of information, they will now manipulate. They will now put some fake information. So respondent bias, they may give you some biased information based on their interest or what they expect to get from that. Okay, so the interviewer can also have the biasness. The interviewer, let's say interviewer, instead of asking some question that he asks from other people, he may just try to patch it when he gives to one person like that. So in that case, the response or the information you have will be with error. Okay, all right. There's also what we call the time period bias. The time period bias. Sometimes, so let me put an example of something like ice cream. Let's say ice cream that blocks in the morning. In the morning. So let's say that in the morning time, the ice cream is blocked. In the afternoon, it will not be as frozen as compared in the morning. Let's say that you were trying to analyze something about the blockness, and you go in the afternoon. You should know already that timing is wrong. So that thing may put some error in your data set. Something like that are called wrong timing. Okay, some infection in human system. At some time of the day, they would maybe expand. At some time of the day, they would just go and gather one place. So if you know this, you have to make a timing that favors what? Reliability of data. So timing bias may also cause error. Okay, after doing that, let's go to data presentation. data presentation. Okay, data presentation is a way you organize your data and present it in a way that makes sense. At the end of a data collection process, you will end up having a kind of unwieldy information, an information that looks like something not useful, such that if you present it to a different person other than you, the person will think that you are just wasting time. Yes. So an area of statistics or a part of your analysis that will enable you to make that information look presentable or looks useful is in the area of data presentation. We have so many methods, important major methods of presenting data. And there are tabular method, and diagrammatic method, and graphical method. Tabular method is a way of presenting information in such a way that it will have frequency and the value of information you have. So another way of calling tabular method is called, we call it frequency distribution. Frequency distribution. A way that you organize your raw data in a form that it have let's say a class which contain the variables and also their frequencies. Frequency mean what? The time or the number of times it occurs in the data set. That's what we call frequency. So how do you present them in terms of frequency distribution? You present this way. And let me emphasize here that so many things we will talk about here can be done manually, and it can be done using some statistical software. The manual one has limitations, and it is not being encouraged nowadays. However, you need to understand the theory involved when you use software or computer. Yes, you need to understand the theories, because once you use computer and you understand the theories, you appreciate it more, and you'll be able to tell stories about information, which is very, very important in the area of data analysis or in the area of statistics. Okay, so let's assume that you want to construct frequency distribution for data you've collected. The process involved is this. You pick the entire data that you have written down, and they pick the values one after the other. Like the entire values contained in the data set, you write them down serially. After that, you go back to data and do the counting process. Now, how do you count? You start with, let's say, you start with the smallest letter of smallest value in the data set. However, you can start from anywhere, but understand and have it at the tip of your mindset that you are counting this particular value, so that you will not count one number twice. So in that case, after writing down the values, what will help you to count what we call the tally. Tally is like this. As you pick a value, you cross it and write. If the value is 1, you just go to tally and draw 1 first and go back and count. The essence of using a tally is not that it is involved in data analysis. No, it doesn't. When you want to analyze them, it doesn't come in. It only helps in counting, so that you will maybe, as you are counting, there's something else that can distract you. And if you pay attention to that thing that distracts you, when you come back, you will not go and repeat that number again. You have counted it already. So the tally has told you that, oh, look, you have counted 1 from here. So that's the essence of using tally. Okay? So as you pick a value, you go and count. As you count, you draw the tally. When you count the tally and reach for, you cross it at the 5th one. Okay? So here we have a data set that is used in practice. If you look at here, so the first thing here was 12. The small number value here was 12. And the right 12 appear only 1. That is why you see tally. You see an eye drawn, and you see the value is 1. If you go there and count 13, 13 will occur 3 times. That's why you see frequency 3. Frequency is what? The number of times that value occurs in data set. Okay. All right. Again, like I would emphasize here that we have 2 types of frequency table. We have 2 types of tabular presentation. The first type is called the ungrouped frequency table. Sometimes we call it the ungrouped data. Another one is what we call the group data. The group, okay, anyway, we'll go to the group, the ungrouped data. Anyway. So next page, please. Let us look at the group data.
Omar, let's move to the next slide.
All right. Group data are those data that, or group table are those tables that the information appear in classes. The difference between group data and the ungrouped data is the class that the group table has. Why do we have the classes in group table? It is because the information is so long or is so distant from each other that if we may want to list it one after the other, you may reach like 200 cells or a set number of cells much more than what what you can contain. So in that case, we have to compress data in terms of groups. For example, let me talk about age now. Let me talk about age of individual now. Let's say you want to obtain information from age of individual. Let's say the entire age of individual that you may have. So age of individual may span from 1 to 100. Yes, it may span from 1 to 100. In that case, if you want to list out ages from 0, 1, 2 to 100, imagine having a list of 100 items on your paper or your computer, which is not even necessary. So in that case, you have to do what? To group some information. For example, you may say, okay, let me group it like from 0 to 10, from 11 to 15, from 15 to 20. So in that case, that kind of presentation is what we call what? Grouped frequency tabulation. Yeah. And the presentation process is also similar to the process of the ungrouped data. The only thing is that when you are counting this particular one, you need to bear in mind that you are counting in the intervals, not as a single number. For example, if you say from 1 to 10, when you look at the list of data, have in mind that whatever I see 1 belongs to same group, 2, same group, 3, same group, until you exhaust the entire interval of class. Okay? The counting process, tally, frequency, the same. Frequency is what? How many individuals do you have belonging to age 1 to 10? For example, here, we have a data set here, which we prepared a frequency table for. If you look at that data set, you will see that the information started from 41 to 85. So if we had wanted to present this as an ungrouped data presentation, we would end up writing numbers serially from 41 to 85, which is unnecessary. And at the end, you will see that the entire number of individuals involved in the entire process is just 22. So some cells will be like 0, 0 if you try writing in terms of ungrouped data. So in that case, group frequency distribution is necessary and it's mandatory in this aspect. Okay? All right, like I said, counting process the same. Everything the same. The only thing is that what? You merge some individuals in some group. You force them to belong to certain groups. Okay? Next page. All right. We now have okay, classwork. Wow, I like this. I like this classwork. Wow. That we have this information here, and you are asked to prepare a suitable, take that note, suitable frequency distribution for the following data. We have not mentioned the type of frequency table you should use. From the explanation I gave with the two nature of frequency table, you may want to go back to that explanation. You will see some, you must have heard some tips about what led to the use of each of the natures of the tables. In terms of, you might want to compress the entire information to be able to minimize the number of spaces you want to use in reporting the data set. So in that case, you have to look for a suitable method to present this. So please try this out. You won't be able to do it here. You can try this out on your paper, and maybe you can snap it and send to me later.
Okay, great. So please, let's take the, when we do the the classwork rather, you can take a picture of it and share once you have it ready. But before we proceed, I just need 1 or 2 persons to tell us which, based on the explanation so far, which of the frequency distribution table do you think is suitable for this classwork? Just chat in the chat room and let's see. Okay, we've discussed 2 kinds of frequency distribution table. So, Boma, can you go back to the previous slide and the previous one? Okay, so this is 1 and this is 2. So this is the first one for ungrouped, and let's move to the other. Okay, for grouped. All right, so this is just a quick recap. So someone chat in the chat room which is best for the classwork while we proceed. Okay, let's have it.
Okay, can we continue?
Who can give that answer? Oh, great. Okay, so someone says grouped frequency table. Great, great. All right. Yes, so we can continue, please.
All right. Okay, we now enter another another aspect of data presentation, which is a diagrammatic method. Diagrammatic method. Just like the name says, in this aspect, we use diagrams. We use diagrams to present the information. So the reason for this is you want to make the data make sense to some persons. Yes, you want to make the data capture some senses at a glance. So in this aspect now, you may want to use pictures. You may want to use diagrams in such a way that once someone just picture the entire, see the entire picture, the aspect of which data was used should not even come into mind, because at this stage, nobody is interested in your data again. What they want is what? The picture. What you created from your data set is what people want to use for decision making. So at a diagrammatic presentation now, you want to create a picture in such a way that once someone just see your picture, the person can tell some stories about it. Okay, I repeat here that in terms of diagrammatic method, computer systems can be used to get even more beautiful picture immediately. Okay, we just want to talk. I want to talk about the theories behind and how you can use the manual method. However, I won't even recommend manual method. Even my students in my school, I don't recommend manual method. But what I recommend to them is that you must understand the theories behind so that you'll be able to tell the story properly. Okay, so we would explain only 2 diagrammatic methods here, which is pie chart and the bar chart. We also have others, something like pictogram. We have pictogram, but we won't talk about. But I think pie chart and bar chart are all often being used to present data in government, in agriculture, and the rest. Even in some text, if you use some textbook, you see some pie chart drawn on it to show you this. There's something you want to capture in the diagram. Okay. All right. So let's start with pie chart. Pie chart is just a circular figure, like circle, in which variables that are being captured in the diagram are sectioned in sectors. Okay, so a presentation in form of circle, and in which the circle is being divided in sectors representing some categories of information is known as pie chart. Okay, how do we draw pie charts? We draw pie chart first by trying to convert the entire information into a circular circle with sectors. So we first of all have to calculate the sectors and name it appropriately. Okay, how do we calculate sector? We calculate sector based on what? 360 degree, because a circle has angle 360. So everything that will be formed in the circle has to be divided appropriately in terms of 360s. So how do we have that? We have that by having some, okay, I think next page will have that. The first, the next, please go to the next page first. Next page. Please, next page. Let's see through the example. Okay. Here we have an example here that says that the housewife spent the following sum of items on buying ingredients for a family Christmas cake in 2023. That will represent information using a pie chart. Using a pie chart. Good. Using a pie chart. And the list of the items the person used are here. So we have the entire list: flour, margarine, sugar, egg, baking powder, and miscellaneous. Okay, and the values of the money in dollar is being listed. Wait for me. Excuse me. Okay. Sorry for the break. This chat is disturbing me so much. So what we do here is we pick a particular item. Pick a particular item, and we pick the value of the item, and then we sum the entire items and have the total number, the total value of the money we have ahead we spend anyway for the entire process. So after summing the entire money across the items, you have 240 here. So how do you have a sector of a circle for a particular item? We do that by dividing the value of that specific item to the entire money spent for all the items, and then I multiply it by 360, the 360 degree. And the value you have is the sector for that particular item. Good. So after doing that for each of the items, you need you just draw out a circle outline. And then after that, you use the item.
Hello, Mr. Coburn, we cannot hear you any longer.
Oh, sorry, let's continue. So after having the degrees for each of the items, you then sketch your circle. And after sketching the circle, what you need to do is to have a protractor. And a protractor will help you to measure the circle sector appropriately for each item. That's how you do until you exhaust the items with their sectors. So that is it with the pie chart, a manual way of doing it. We have a simpler way of doing it, which is what? The use of computer. So I don't know if we would have creating it using a software.
Okay, yes. Just a minute. Let me share my screen.
Okay.
All right. So please confirm in the chat room that you can see my screen.
Personally, I can see it now.
Okay, good. All right. So let me quickly pair this with. Okay. So before I extend my the Excel again, so this is the slide we're looking at, right? So what you see here, this is, I've already done this, but we're going to do it again. while in class. So this is basically the simplest form of doing it using the simplest formulas in the cells, which I'm going to show us how we got the pie chart and all that. So this is what we're going to, what we're looking at. And let's quickly do it all together. You can see here, right? We have all you have here, 24, 96, 18, 60, 12, 30. We have them all here. All right, so we're going to use a formula to compute and get the figures, the angle of sector, and then have the pie chart drawn. Okay, so let's go back to the Excel completely. Okay, so I'm just simply going to replicate what has been done up here, right here, so we'll get to see. So the simplest, if you're using Excel, right, and you're going to use formulas, there are simple formulas that you can use. I guess some of us on the call already know this, or some do not. So we're going to do this together, and it's quite simple. If you're going to do any form of addition, subtraction, multiplication, division in Excel, you have to always start with equals sign. Okay, so remember the formula is to divide whatever you have in this cell, divide 24 by 240, which is the total, divide 24 by 240 and multiply by 360, if you remember the formula. So we're simply going to do this. 24, you can see 24 is, okay, let's go back. 24 is in the cell, in this cell, B18, B18. So instead of calling, just writing 24 times whatever, you can refer to the cell. Okay, so we're going to do that. So we start with equals. So we have B18. You can see it's been selected. B18 divided by 240 is what the formula is. And then you close brackets. Then multiplied by, okay, if you're using the system, multiplication sign is not the X sign, it is the asterisk sign. Okay, so multiplied by, open bracket, 360, close brackets. So when you click your enter, it gives you the figure, the result, or the answer. So let's go back to the PowerPoint. You see, so for the first angle of sector, you have 360 degrees, and that's what we have here. Now, to duplicate this for the rest of the cells, all you have to do is make sure you select the cell which has the answer, the correct answer, and run it down. Okay, before you run it down, when you bring your cursor there, it has to turn to the plus sign. Okay, if you still have it as this, you cannot run it. You have to bring it to the edge here and then drag it, click and drag it down. So the answer would duplicate its, the correct answers will be filled up because you've put the correct formula up here. So the correct formula will be applied to the rest of the cells. Okay, and then for you to check if you actually have the total of this as 360, you simply would have to select all the field and go up here. Select all the field and then go up here. You see this summation, auto sum, okay? You click it, so it gives you the total figure. It is 360 degrees, so that's good. Now, how do you transfer this information or this table to a pie chart? So you have to select it, and then you see, you go to the bar up here, right? And then you select the insert button. You see all these are different charts, both bar chart, pie chart, and what have you. So we're looking for pie chart. So I will drop down. I would like to go with the first, or if you choose this, fine and good. So I prefer to use this. So I select it. The moment you select it and click on it, whatever you have in this field automatically will be represented in a pie chart. So you have it represented in a pie chart. It is that simple. All right, so this is the simplest way to represent data in pie charts. For those of you who already have idea of this, this is just a simple knowledge for you. But for those who are not, this is the easiest way to represent a pie chart. As you go further in your fields or careers, then you advance to the bigger part of this. But this is just the simplest way as far as pie chart is concerned. Okay, so I hope we got that right. You might have later on when we share the link to this recording, of course, you can always watch and see how we did that. So it's this simple. Okay, so we proceed to the bar chart part of it. I think I would stop sharing my screen now while the lecture continues. Okay, Coben, over to you.
All right, you see how interesting and even more beautiful it is using a computer. It's very interesting using computer. Just understand the theory behind and go ahead with using computer, and it's very interesting. And the question now is, if in case someone is interested in your analysis, and maybe the person wants to look at which aspect that or what item consumed money most. So merely looking at the picture, an item that has the larger or the largest sector is the one that consumes the money most. So that's the extent. At times in a country, at times when they want to present budget, they use something like this, something like to present the entire budget in such that even those persons that don't have much idea about numbers, once they see the picture tells stories even better than numbers. That is why this aspect of presentation is very important. Okay, let's go to bar chart. Bar chart is also a diagram, but in this case, instead of having a whole sector or whole circle, we present these values or these items in terms of bars, a rectangular bar. So for bar chart, you will see a figure that has so many bars, each bar representing an item. And the length of the bar means how long a bar determines or tells the story about how large the values are in that item. So, for example, the one we just presented using a pie chart here, it can be presented using bar chart too. And in that case, margarine would have the longest bar. So a bar chart is what? Is also a diagram which enables you to present information. However, the information or the items here will appear in bars. Okay, we have 3 types of bar chart, and these 3 types are the component bar chart, the simple bar chart, and the multiple bar chart. While simple bar chart is used to present single information, the multiple bar charts are used to present information in which there are categories in the items. For example, if floor here has other categories, okay, in that case, you will not be able to apply simple bar chart. You apply either component or multiple bar chart. Okay, in this section here, you will see examples of items that were presented using both simple bar chart and a multiple bar chart. If you look at the first example here, example 2 here, you will see that we have a sample of 250 students that were asked about their favorite TV channels, and their responses were as follows. Okay, so you can present them using bar charts, which I think they did would also take us through the process of creating this particular bar chart. Yes, so the second example is the one that has to do with component bar chart, which, as you can see here, the information has the cocoa and palm oil, and also the products were sold in different years. So the years there can form categories, and even you want to categorize it based on the products, you can categorize. So in that aspect, you would be able to have a clear picture if you present it using simple bar chart, because you cannot just have simple bar chart that that contain the appropriate bar chart to use there is what? The component bar chart or even multiple bar chart. Please, Edith, I think you have a clip on how to use a computer. Can you help us through this process?
Yes. Okay, sure, yes. Okay, Boma, you can stop sharing it so I can share. Okay, so here we go. Okay. So we have on the screen, this is the slide we're working on. Mr. Coburn, your video is on and we can see your baby. We can see you and your baby. Okay. So now this is the slide we're looking at. I mean, looking at this particular image here, I can remember back in school while we used the graph to do these things, right? But good thing we have technology and it has simplified everything. So we're going straight to see how this is done. So I'm just simply going to delete what we have here. Okay. All right. So this is the table we have in that in the PowerPoint. This is this particular table right here. So just to represent it in a bar chart, all you have to do is select it and go to the insert and look for a bar chart. Select and look for whichever type of bar chart you want to use, right? Whichever type of bar chart you want to use, you just have to select. So I prefer to use this. It's very simplified for the sake of this class. So you just simply click on it and it represents it.
Ma'am, we can't see your screen. This is the PowerPoint that is still
really?
on display. Yes.
Oh, okay, hold on. Okay, can you see my Excel sheet now?
Yes, we can now.
Okay, so let me do that again. So I simply would have to delete this. So this is the table we have in the PowerPoint, right? So I would simply have to select it and go to the insert. And here we have the bar chart, right? So I would select and then choose whichever one appeals to me. So these are different types that you have here, right? So you can choose whichever one appeals to you, and I would just choose the most simplified form of it, and this is it. So you simply click on it. I mean, there are a whole lot here, so you can decide, right? It's up to you, whichever one appeals to you, okay? So I chose the simplest form, and here we have it. So this is simply represented in a bar chart. And we also have the component bar chart, right? The component bar chart, I would simply delete this. Let me also delete this. So if I select this and go to insert, I can choose, or rather I can go to, let's say this, or I simply would go to if I choose this, I can come here and decide which other form, right, that appeals to me. Or better still, I can choose this. Okay, so it's up to you, whichever representation you prefer. So you can see it tells you that the one in blue, all the ones in blue has to do with agricultural produce, coffee, right? So you see coffee here, all the one in blue. So it simply tells you, this is the key. It simply tells you, and all the ones in ash up here tells you it's palm oil, as you can see, palm oil here. And all the ones in orange tells you it is cocoa, which is this. So it's a simple way of representing this in a bar chart. And it's very beautiful when we do these things with the system. Unlike back in school when we used to draw with the graph and all that. So thanks to technology. So I hope this helps. Okay, so I'll stop sharing my screen now and we continue with the class. Okay, Mr. Coburn, over to you.
All right, thank you, Edith. All right, we now head to graphical methods. We are done with like I said earlier, we have 3 methods of presenting data. We have a diagram, we have the tabular, and the last one is the graphical. Now, the graphical method is the use of graphs. The use of graphs. And in this case, it's not just an ordinary diagram again. It's a diagram that respects the origins of graph. The x-axis and the y-axis need to be taken care of in this case. Okay, and we have types of we have so many types of graphical method here. We have histogram, we have frequency polygon, and we have the cumulative frequency curve, which is otherwise known as the OGI. Okay, and we start with histogram. Histogram is also a picture that looks like a bar chart. However, the only difference between a bar chart and a histogram is that in bar chart, you will see gaps between the bars. You will see gaps between the bars in bar chart. But in histogram, there is no gap. Everything is compacted. What's the reason for this? The reason for this is that we use histogram to present continuous data. What do you mean by continuous data? Data that do not have jumps. For example, now let's say I was talking about age groups 0 to 10, 11 to 20, 21 to 30. If you listen to that those age groups, I have jumped from number to number. For example, now, like I said, from 0 to 10, then 11 to. So between 10 and 11, I have jumped some numbers. So in that case, before you present it on a histogram, you have to deal with that. You have to remove every jump before you can use histogram. In bar chart, we present information that has jumps. For example, if you say 1, 2, 3, between 1 and 2, there are some values between 1 and 2. For example, now 1.1, 1.2, 1.305, 1.9, there are some values. And some data, okay, some information can contain data that looks like that. So in that case, if you present it using bar chart, you will mill out some information. For example, if you are presenting like 1 has bar, 2 has its own bar, 3 has its own bar, the information concerning 1.5 will not come in. In that case, you have lost the entire thing. So the essence of presentation is to do what? To ensure that every element is taken care of, every value is taken care of. So in that case, you have to move into a somewhat kind of diagram that will be able to handle those gaps. And that thing is what? The graphical method. For example, in this case, the histogram. So a histogram is like bar chart though, but the issue of what? Gaps has been what? Removed to take care of, or to take account of what? Those values that bar chart cannot take into consideration. Okay, so here we have an example here that we use the histogram on. But however, before we use histogram, like I said, we have to change from the table that has jumps to a table that is continuous. How do we do that? We do that by removing those discrete jumps. For example, now, the example we have here says that you should construct a histogram to represent the data below. And that data, we have it from 100 to 104, and the next class is from 105 to 109. So in this case, between 104 and 105, there could be information. So in that case, we don't want to miss out of the information that could appear between those intervals. So what do? We convert it to what we call a continuous class. And how do we convert it? We convert it by doing what? By subtracting 0.5 from the lower class limit. The lower class limit is the end of the class, the end of the smaller class anyway. For example, now 105 and 104. 100 and 104 are the lower class limit and the upper class limit respectively. 105 and 109 are the lower class limit and the upper class limit of the second class respectively. 110 and 114 the same thing. So what do you do in this case to be able to convert it to a continuous class? You subtract 0.5 from the lower class and add same to the upper class. That's why in the solution here, we have 99.5 at the lower class and 104.5 at the upper class, meaning that we have subtracted 0.5 from 100 and it remains what? 99.5. And we have added 0.5 to 104 and become what? 104.5. We practice that across the entire classes. That is why if you look at the solution, you have 0.5, 0.5, 0.5. And if you check that, the end of the first class becomes the beginning of the second class, meaning that we have eradicated what? Those jumps. There is no limit again. It becomes what? Continuous. If you check the first class now, you see 105 being the end of that first class. If you go to the second class, you see 105 again, being what? The beginning of that next class. Same thing appears across the entire classes. And once you have done that, you start the plotting. And the plotting is still the same process as the bar chart. However, in this case, we respect the lining of graph book. That is why for graphical method, we use graphs. We do not use ordinary paper again. We use graph because what happens, the naming of the classes, the labeling of the classes have to be taken into account. Okay? So after that, if you have a graph book, you just draw the origin, the x-axis, and the y-axis. The y-axis represents what? The frequency, always, take note of that. The y-axis represents what? The frequencies. And the x-axis represents what? The value of the variable. Okay? So in this, our example, the variable was talking about what? The temperature. So temperature represents what? In the x-axis, and the frequency is at what? At the y-axis. So after doing that, you just start with the normal naming, starting from what? The lowest class, which is 99.5. You started with that and just name them accordingly to exhaust the classes. After that, just plot out your histogram as if you are doing what? Bar charts. And you will see how everything is compacted. No more gaps between the bars. After that, we want to look at the frequency polygon. The frequency polygon. The frequency polygon is just like a line graph. However, we have a very simple way to work that out. How do you work it out? We work out by joining the middle of every bars in the histogram. So before you can plot out, or you can plot out the polygon, the first thing you need to do is to construct a histogram first. And after constructing a histogram, you then join the middle of each bars together. After joining that, you will have your own frequency polygon. Please, next page. Okay, so for example, you see here, we have a frequency table here, and you're asked to construct a histogram and a frequency polygon. Even if you are asked to construct only a polygon, I do tell my students that the simplest way they could work that out is to work through histogram. Although there's another method anyway, but what the simplest way is working through the histogram. So just draw your histogram, normal histogram. After doing that, you now look at the middle of every bar, the center of every bar. Locate the point. Just locate points at the center of every bar, and after that, you join those centers to each other bars appropriately. And what you have now is a frequency polygon. Okay, the next thing here is to look at the method, which is OGI, or cumulative frequency curve. Okay, cumulative frequency curve is a curve plotted with the cumulative frequency against the upper class boundary of the classes. It's a curve plotted with the cumulative frequency against the upper class boundaries of every class. Before we go into that, what do we mean by cumulative frequencies? And what do you mean by upper class boundaries? Okay, the cumulative frequencies, I think we work that out in the next page. Let me start with the explanation about the class boundaries. Class boundaries are the end of the classes that are continuous. Class boundaries are the end of the classes that are continuous. Why class? End of the classes that are not continuous, and the non-continuous classes. The non-continuous classes or discrete classes are those classes with jumps. Please type continue for me to be sure that the audience are listening.
We can hear you. Please go ahead.
Is someone out there?
Can you hear me?
Okay, I can hear you. Hope others can hear me
ahead.
too.
We can hear you. Yes.
All right. So okay, let me start all over again. I was talking about how cumulative frequency curve can be plotted. Okay, it's the curve that is plotted with the cumulative frequencies against the upper class boundaries. A curve plotted with cumulative frequencies against the upper class boundaries. Now the question is, what do we mean by upper class boundaries? What is a class boundary? Okay, class boundaries are the end of the continuous classes, whereas class limits are the end of the discrete classes. A discrete class is a class that has jump, whereas a continuous class is a class without any jump. For example, In the example we have here, in table 1 that was not worked, okay, the first table that was not worked, you will see that the classes start with, okay, the first class started with 14. The third class started with 15 and ended with 19. If you look at these classes now, the end of the first class is not the same as the beginning of the next class, meaning that between 9 and 10, there are gaps. So that gap makes it what? Discrete. If you look at the table 2, table of the solution, you will see that the end of the first class is the beginning of the next class. The end of one class is the beginning of the next class, meaning that everything is joined together and that's continuous. So for the continuous classes, the end of those classes are what we call what? The class boundaries. Whereas the end of the classes that are this is what we call what? The class limit. So when you want to plot a cumulative frequency curve, you must ensure that you convert every class to a continuous class and then pick the upper class boundaries for all the classes and plot it against what? The cumulative frequency. So the next page. Next page. So the next page is how we show how cumulative frequencies are worked. This is not the page. Go up once again.
Are you still there? We cannot hear you.
Please.
Okay.
Can you hear me?
Yes, go ahead now. We can hear you.
Okay, what I said is you have jumped a page. Who controls this should go back one step upward before we can, so that we can finish up with what we're explaining.
Okay, you mean one step backward, right?
Yes, yeah.
This was where you were before.
That means you have omitted one slide. The slide you omitted is the slide that the example of cumulative frequency curve was done.
Okay, let's check that. Or is there a way you can just go on with your class, then while we sort for that?
Okay. All right. Okay, so what do you mean by cumulative frequency? A cumulative frequency repeatedly until you exhaust it. Summing the frequency of each class with another class until you exhaust all the frequencies is what we call the cumulative frequency. You sum it the first, for example, now, if you want to find the cumulative frequency for this
Even your network is breaking. We cannot hear.
Hello?
Yes, you are clear now. You are clear now.
Okay. All right, so let's look at the measures of central tendency. Okay, measure of central tendency has to do with the numerical calculation that finds the center of the distribution around which other values cluster. Measure of central tendency is an important aspect of statistics because it gives a single value that can be used for a whole lot of explanation. For example, someone can, you keep hearing about the mean monthly income, the mean annual expenditure, the mean revenue. What happened is that those things they mentioned is not just a value that was obtained from data. It's a central value that was calculated from data set. Let me give an example of why these values are so important. Let's assume that you were given an assignment to train some students on a particular concept. And I believe you are hearing me now. Is someone hearing me?
Yes, you are
We can
audible.
hear you.
Yes, you are audible.
Okay. So let's assume that you were given a task to train some persons on a particular program. And after training now, then you administer tests to the trainee to understand how they understood the training. And let's say at the end now, the person that sent you to train, they want to access how your trainee performed. Okay. Now let's say that you score each trainee between value 1 to 10, all of them now 1 to 10. Let's also say that let us also believe that you have like 50 trainees. So now let's say you want to go and explain to the person that sent you how your student responded to the training now through the test you administer to them. So if you are in the presence of your boss now to explain,
Your network is lagging again. We can't hear you.
5, second score 9. Let me be able to go along with this. What center
Mr.
of those
Koban,
scores?
can you
The
take that
average
again?
score is 5. Hello?
Mr. Koban, yes, your network was lagging, so we weren't hearing you. Can you take that again?
Okay. Listen, I'm explaining why and how useful measures of central tendency is. Maybe you can hear me.
Yes, I can hear you.
I'm
Okay, we can't hear you. Can't hear you. We can't hear you. Hello. Hello, Mr. Coburn, we can't hear you. Your network is really lagging. Hello.
Can you hear me now?
It's still lagging. Can you say something again?
Yes, even me, I can hear you clearly. Can you hear me now?
Yes, I can.
You can hear me now,
Hear
right?
you now. All right, let's go.
Okay. So I'm still explaining how and why the use of the measures of central tendency is so important and crucial in every analysis. I'm talking about now a case that someone has an assignment to do, and the person has to report back to the boss about how the assignment went on now. Okay, let's say for example now you trained individuals on a particular concept or a course, and at the end can you hear me?
Yes, go ahead.
Okay, let's say that at the end now you give a kind of test to
James, can you hear him?
I cannot hear him as well. The network
he has
from his,
left.
Oh,
from his end, I can't hear him.
No, he's back now. He's back now, but he's not speaking yet.
Mr. Coburn, can you hear us? Your network is seriously lagging. We can't hear you. And you are muted as well. In case you're speaking, please unmute your mic because we can't hear you.
Can you hear me now?
Yes, I can hear you now.
Okay. All right, let's continue with the measures of central tendency. I start afresh now with the hope that the network will not disturb anymore. Okay. The measure of central tendency is a statistical measure that enables us to find the center of the distribution around which other values are clustered. Those values which can enable you to tell a whole lot of stories about numerous data or about a large set of is the measure of central tendency. I mean, finding the center of the distribution. The measure of central tendency is very important in analysis because it presents you with a value that contains so much of information about a particular purpose. For example, we do hear about the daily languages, so something like this: the mean monthly income, the mean annual rainfall, the average expenditure. All these are measures of averages that tell a lot of story. Let's say, for example, you want to introduce a product in a particular region, and this product require some class of individual with certain amount of incomes to appreciate them. And yes, there are some products that require higher class of individual to patronize them. Okay, let's say you are dealing with that product now, and you need to find out if those living in that area will be able to patronize you. What you do is to go on maybe research on that zone. Okay, now let's say that after the research, you have collected information from, let's say, 500 individuals. What you need that will guide you enough is the average of those expenditure, and not so is the average of those incomes, and not the income of the individual persons, because you may not even be able to go through all the incomes paying individually. No, it may be so difficult. So if you have the average is what will direct you. The average is just a number at the center which guides you to tell a lot of story about your analysis. Now, what are these measures of average? We have arithmetic mean, we have the harmonic mean, we have the geometric mean, we have the median. Those are measures that will calculate values that lie at the center. Okay, now we start with arithmetic mean. I hope someone can hear me.
Yes, I can hear you. Please go ahead.
Okay, so we start with the arithmetic mean. Arithmetic mean is one of the measures of central tendency, and like people do say, it's one of the most important measures of central tendency. The reason being it takes into consideration all the values in calculating okay. So how do we calculate the mean now? I think mean is very easy to understand and it's very easy to calculate. How do we calculate mean? Let's say you have some data set from x1 to xn. Now, what is x in statistics? We use x to denote a value. I repeat, so from now henceforth, whenever you see small x statistics is what? We use that small x to denote what? A value. So you can put in any value there and do your calculation. So we do like this. Mean is what? The sum of the entire values divided by what? The total number of data sets you have. So let's say you collected information from 50 persons. That is n. The total number of data sets. So n is what? 50, because the entire information is collected from what? 50 persons. And now the numbers or the information collected per individual is what? X. So if the first person gives you 20, that is x1 is 20. If the second person gives you the value 25, that means the x2 is what? 25. If the last person gives you 50, that means xn, the x of the number of the last one is what? 50. Hope you understand that. So when you find out the mean, you just sum the values and divide by the total, and we call that what? The arithmetic mean. However, if you are working with a frequency table, I think because here we've discussed frequency table, a table that can group data into frequencies, okay? So if you are working with such an information, the way you calculated mean changes because you have to take into consideration the frequencies of each
Mr. Okobong, we cannot hear you. We cannot hear you.
What about now?
Okay, yes, we can hear now.
Okay, that means I have to move this in close to my face. Okay, hope you can hear now.
Yes, loud and clear. Loud and
Okay,
clear.
so for you to find mean, you sum the entire information you have and divide by the total number of persons or total number of individuals you obtain the information from. So if you had collected data from 50 individuals, and let's say you were trying to understand about the mean monthly income of individuals in a particular region, okay, and you go into the household to make inquiry how much they have per month. So let's say the first person tell you that they have 100,000 per month. The second person tell you, okay, the second person tell you they have 50,000 per month. So X1 is what? 100,000. And X2 is what? Is 50,000. And let's say that the last person you obtain information from tell you that he or she earn 20,000 per month. That means X subject N is what? Is 20,000. So in that case, once you sum the entire values of the monthly income and divide by the total number of individuals you obtain the data from, it becomes what? The mean monthly income of the person in that region. So let's look at an example here you have. We said that you should find the mean of the numbers 2, 4, up to 12. So that's why you see find the mean with sum. Okay, you see 2 plus 4 plus up till you have 12, all by 6. 6 is because we have the number of data points is what? 1, 2, 3, 4, 5, 6. Yes, that's what you have over 6. And dividing that gives us 7.7 and 1 over 3. And one other thing is that when you are reporting mean, you can report with decimal numbers. For example, now, like This one I'm reporting like 7 and 1/3. It can be 7.1, 7.2, 7.3. There is no issue about the way you report it, as long as you calculate it very well. I hope that is clear. There is an exercise here for us that says that we should find the mean of this. Okay? So even without writing down much things, you can just have a paper with you and just add this and divide and give us the mean as we progress. Please go to the next slide. Hope you can hear me, right? Okay.
Yes, please.
Table. We talked about frequency table before. So if you want to find mean from a frequency table, you have to apply a different concept that enables you to take care of the frequency. You know, frequency table has to be what? The value of that variable and the frequency that represent the number of times that value repeated in the data set. So you cannot find mean here without taking into frequencies. Okay, and how do you find mean when frequency is involved? We find mean by, first of all, multiplying the value of the variable by the frequencies. Okay, so if you look at the solution here, we've multiplied them out. So we say, okay, since we have the mass, okay, I think we are trying to find out the mean of the mass of 50 men. Okay, that is presented in the table here, and the table the mass and the frequency. So in the table, the people that had the mass 59 were 3. The individuals that had their body mass 60 were 9. And
Mr. Coburn, we can't hear you any longer. No, we can't hear you. Okay, I think he's been disconnected from the call. So give us a few more minutes while we have him back. And I think on this slide, we would also take practical application on how to work on this in Excel when he's done with this slide. Okay, Mr. Coburn, you're back, I can see. You can unmute your mic. Please unmute your mic so we can hear you. Your mic is still muted.
hello.
Okay, I can hear you.
Can someone hear me?
Yes, I can hear you. Please go ahead. Go ahead. Hello, Mr. Coburn, please go ahead. And please unmute your mic.
Hello.
Okay, I can hear you now. Please go ahead.
Sorry about this network issue. I have changed location now, and I believe this particular place will be okay.
Okay, that's fine.
Were we able to get to the point of finding example of calculation of mean from a frequency table?
Yes, this is the slide where you stopped.
Okay, so let's continue from here. And I talked through the that this is different from the other one. There was no frequencies, and in this particular one we have frequencies, and as long as the value of the data. So, for example, now we have those with the body mass 59 kg were 3 persons that were measured, and those with the 60 kg were 9 persons. So the 9 persons here are the frequencies, meaning that the number of individuals that weighted 59 kg were 3 and 60 kg were 9. So in that case, before you can have an appropriate measure for mean, you have to calculate it to take care of both the body mass and also the frequencies. Okay, so how do we calculate that? We calculate that by multiplying the value of the masses by the frequencies, and then divide the sum of those multiples by the sum of the frequencies. Okay, so for solution here, you see how we tabulate it. You see how we tabulate it now. We write the masses, we write the frequency, and we sum. That sum we call Fx. Fx means what? Sum F by, okay, multiply F by X. Like I said, X is what? The values. Whenever you see X, they are the values. So F is the frequency, so we multiply them together. So the first that we have here is 177, which is 59 multiplied by 3. So multiplying everything across, we have the sum give us 3054, 3054. And we also sum the frequency. We call that the total frequency, which will represent what? Total number of individuals that presented their weight or their body mass, which is what? 50 individuals. So dividing the 3054 by 50 give us the mean, which is what? That the mean body mass is 61 kg. Now, I do also talk about the meaning of that. The meaning, I think I've tried to explain earlier, that it has a big meaning. It's not just the number, it has a big meaning. So if you are interested in knowing about the body mass of individuals there, maybe there's something you want to do that require a knowledge about the body mass of individual in that group. So in that case, you can go ahead and tell somebody, oh, the average body mass of individuals there is 61 kg. It's very important in telling the story because you won't be able to go across telling the mass of individual for each person across the 50 individuals. It's not very useful than this single value you've calculated. That will say, okay, if you want to work with them, understand that the average body mass is 61 kg. Okay, all right. I believe this process also. I believe this process is a little bit cumbersome if you are using manual method to calculate them. And like I said earlier, we also have a good method that enables us to find this thing out. You only need to understand the process and the basis, so that when you apply the computer system, you can understand the process through which the system work on. So please, Edith, I think you have a clip that would put us through the use of Excel to work this.
Yes, and I'll be sharing my screen shortly. Okay.
Hello?
Yes, I'm sharing my screen now.
Okay.
Okay, please confirm if you can see my screen. James, can you see my screen? Hello, James, can you hear me? Please confirm in the chat room if you can see my screen, somebody.
Yes, I can see your screen. Yeah.
Okay, good. All right, so working on this exercise in Excel. All right, so you can see here, let me make this bigger. Okay. So this is the exercise we have here, right? So I simply transferred this, right? I simply transferred these figures or this record into the Excel, right? So you can see here simply how to get the FX, like I've explained earlier on. It's simply you starting with the equals formula, equals sign first. So we're going to do this one together, but let's simply look at what we did here. So you simply put the equal sign, knowing that FX simply means F times X. So whatever is in this cell multiplied by what you have in this cell will give you answer here. So simply you have B3, which is this, multiplied by A3, which is this. And then when you use your enter key, it gives you the answer, and then you simply drag it all the way down, right? It duplicates itself. And then to get the mean, you already can see the mean here is the summation of Fx divided by the summation of F, right? So we have Fs here. This is the summation of Fx. This is the summation of F. So here you can see the formula here too. Is simply summation of Fx, which is C8. C8, that is the cell, divided by summation of F, which is B8. And that's what you have here. And then when you use your enter key, it gives you the answer. So here below in the PowerPoint, you can see the classwork. So we're going to do that classwork together for easy understanding. So I'll simply delete all that. All right, so we have our F. Let me take this out. Okay, so we have our F and we have our X. So to get this, you're simply going to have equals D. This is D, C rather. C16 multiplied by B16, and then your enter key, and you simply drag it down and you have your figures, right? Simply to get the summation, like I said earlier, you would just have to drag all through, sum it all together, and you have that. Right, so now to get the mean, remembering that the mean is simply the summation of Fx divided by the summation of F. So we're simply going to use equal sign. Equal sign. Summation of Fx is D21. So D21 divided by C21, and then equals. You have your answer there. So that simply is your mean. So all you just need to know is to know how to use these simple formulas. These are the simplest ways of using the formula in Excel. But of course, as you advance, you go deeper. There are lots and lots of formulas and complicated formulas as well when it comes to the use of Excel. But for the sake of the class, these are foundation. And yes, so that's simply how to do the classwork. And if you go back, if you go to the solution of the classwork, you see that we got our answers correctly, right? So you have the summation here, you have your mean, which is this. So yeah. So Boma, are you still there, or I should share the screen I should continue sharing the screen?
Ma'am, I can take over now. Thank you, ma'am.
Okay, all right, great. All right, so Mr. Okobong, over to you.
Okay, thank you very much. Okay, thank you very much, Edith. We now go to median. Median. Median is also another measure of central tendency, and median is just the number at the center, the value at the center when you have arranged the entire data set in either ascending or descending order. So median, find the center through this way. If you are working with data sets that are not grouped or that do not have frequency, what you do is you rearrange the value in ascending or descending order of magnitude. And then after rearranging them, you locate the number at the middle. Remember, this measure is about what? Finding the center of the distribution. So after rearrangement, the number that appears at the center is the median. That is, if only one value appears at the center. However, if there are two values that appear at the center, what you do is to find the average of the two values, like finding the mean of the two values by summing them and dividing by 2. And that will give you the median. That is for ungrouped data. Now, if you are grouped the data, if the data is grouped, like the data that come with frequency table or intervals, the stories change. So in that case, what you do is to apply the formula that appears here. That median equals to, I believe you can hear me.
Yes, go ahead.
Okay. That median equals to the lower class boundary of the median class plus, you open a bracket, the total number of individuals in that group plus 1, then dividing by 2, minus the cumulative frequency of the median group, then divide all by frequencies and multiply by the class magnitude. Okay. So that is the formula we apply when we are talking about finding median of a grouped distribution. That is the formula we use. Before we get to an example of that, I want us to also talk about this mode first. Mode, before we go into the calculation process. Mode is also the measure of central tendency. But mode talks about what? The number that appears most in the distribution. For example, if you are obtaining information from 50 persons, and at the end, you are the most people that reported. That means the mode age is what? The modal age is what? 45. So that's it. That's it about finding the mode for ungrouped data. But if the data is grouped, if you have them on frequency distribution, the story also changes by applying a formula. So you don't just pick a value in that case, you do what? Apply a formula. And meanwhile, let me emphasize that for you to apply the formula, you need to identify what we call the class that contain these numbers. For example, in median, the first thing you need to do is to obtain what we call the median class. After all, without having a median class, you won't be able to find a median. A median is embedded in a median class, and also the mode is embedded in the modal class. So the first thing is to obtain the classes first. This formula. So we will see that in our next example. We'll see that in our next example. So the example here says that you should example here says that you should and mode. We won't bother about mean. After all, we know how to find mean. We won't bother about mean anymore. The only thing we bother about now is the median and the mode. Please, the next section, please. Hope you can hear me there.
Yes, we can hear you. Boma, the next slide.
All right, okay, okay. We now find the solution to that example. Okay, we were unable to calculate cumulative frequency in the other example. So good enough, the cumulative frequency has appeared here. You cannot obtain median easily without having cumulative frequency. Okay, so we would calculate that all together here, so as to help us to apply that in finding the median. Okay, so we use the table in the example to work this out. So that table gave us the class boundaries and frequencies alone. It gave us the class boundary and frequency alone. If you go back to that, you see that you have only the class boundaries and the frequencies alone. But here, we will extend the table to include those parameters that are needed in the formula we want to use. So those parameters are what? There is the cumulative frequency, and also the midpoint is also needed, and the frequency is all okay, was given already. So the column here, sorry, the row here, CF, is the cumulative frequency. CF means cumulative frequency. So how do you find that? We find that by accumulating the frequencies that we're given. By accumulating the frequencies that we're given, we will obtain the cumulative frequencies. And how do we accumulate that? If you see CF for the first class boundary, you will see that the frequency was 5 and the cumulative frequency is also 5. Why is it like that? It's because there was no any previous frequency that should be added to that 5. Okay, so we just add 0 to 5 and we get 5. Now for the next class, which is 9.5 to 14.5, we have the cumulative frequency to be 17. Why is it 17? It's 17 because we have added the previous frequency to the present frequency that we have added 5 to 12, and it gives us 17. That's how we accumulate the frequencies. So the next column, we have the CF to be 89. Why is it 89? Sorry, we have the CF to be 49. Why is it 49? It's because we have added 17 to the frequency of that class, which is 32. So 17 plus 32 is 49. So that's how we obtain cumulative frequencies across all the classes. Please check that. That's how we have them. Okay. Now, after that, you have to locate what we call the median class. That is the first thing. We use cumulative frequency to locate the median class. So listen to how we look at the median class here. We look at the median class first by dividing the total frequency by 2. So divide the entire frequency by 2. So the entire frequency is 120 persons. Sum the frequencies, you give 120. So you divide that by 2, it will be 60. Okay, so having 60 now as the total frequency, what you need to check to do is compare that n over 2 with the list of the cumulative frequencies. Anyone that is just greater than that is the class that contains the median. I come again. How you locate the median class is by dividing the total frequency by 2 and comparing the result to the list of the cumulative frequencies. Any cumulative frequency that is just greater than n over 2 is where the median class lies. For example, in this case, if you divide 120 by 2, you have 60. Now, compare 60 to the list of the CF. You see that 89 is the value that is just greater than 60. Yes, 89 is that value. So what you need to do is to trace that 89 to its own class. The class is what? 19.5 to 24.5. So anything you work on there is within the class. There is nothing else you can do. So the formula is applied in the median class and nowhere else. If you apply that in another class, that means you are computing something wrong. So locality is the first thing to do. Same thing goes to mode. If you want to calculate mode, the first thing is to identify or locate the modal class. How do you locate the modal class? The class with the highest frequency is the modal class. The class with the highest frequency is the modal class. So in this case, if you check through the entire frequencies we have, the frequency 40 is the highest. Frequency 40 is the highest. And which class contains that frequency 40 is 19.5 to 24.5. So you apply that formula in that class 19.5 to 24.5. Okay. Now, after you must have located the group, whether the class, whether the modal class or median class, depending on which one you want to compute now. LCB is what? The lower class boundary of the modal class. I think I've talked about class boundary earlier. That the class boundary is the end of the end of the class. The end of the continuous class is the class boundary. And good enough, this question came with a continuous class. I didn't mean it came with a discrete class. It will be our work, or your work if you're the one to calculate, to change that discrete class to a continuous class by subtracting 0.5 from lower class limit and adding to upper class limit. Okay, but see, this one came originally with a continuous classes. You don't have issue with that. Okay, so the lower class boundary is the one that is smallest within the class of interest. For example, in this case, since the class that contains the median is 19.5 to 24.5, 19.5 is the lower class boundary. You see how it is. The lower number in that class is the lower class boundary. Okay, yeah, very simple. And the next thing there is to locate other parameters. Okay, so one other parameter is what? N plus 1. We know the meaning of N. N is what? The total frequency. So N is 120. N is 121. So N plus 1 is just 121 over 2. The next thing you do. So the next thing is to go to CFA, which is the cumulative frequency of the class presenting that median class. So what you need to do is write down these parameters one after the other, such that when you want to calculate them, you just fix the parameters at appropriate place and calculate, and that is done. For example, like all over F. F means what? The frequency of that class. The frequency of the median class. So if you look at that frequency is what? 40. That's why you see over 40. What again is something that can be difficult to identify. Okay, you see here, multiply by I. I is what we call the class width. The class width is what? How larger or smaller is the class? The value of that class. So the class is counted like this. The class started from 19.5 to 15.5. If you subtract 14.5, if you subtract 9.5 from 14.5, you have 9. You have 5. Sorry, you have 5. So that's why you see that I is what? 5. So that's it. So that's how we calculate it. Same thing goes with the calculation of mode. calculation of mode. Let's go to calculation of mode. So what you do first is, like I said, to identify modal class, which is the class that has frequency 40. Okay, so after picking that class, you then locate other parameters. For example, f of A is the frequency after the modal class, and f of B is the frequency before the modal class, and f is the frequency of the modal class. So those statements are so plain that once we see the name of that parameter, you can as well know the value you want to use. So please, if you are working with this formula, go back to where we define each parameter, because whenever a formula is given, the definition and the meaning of each of the parameters involved in that formula has to be defined explicitly, so that even those that are not very familiar with the formula should understand what it means and how they could be obtained in a data set. Okay, so we have an exercise here anyway that says that we should find the mean, median, and mode for this frequency. Please, you go and try this out. Yes, on your own. It's very easy to calculate. Learn how to obtain modal class. Learn how to obtain median class. Then learn how to apply this formula so as to obtain the needed value. Okay, we now go to other measure of central tendency, which is the geometric and the harmonic mean. Anyway, although these ones are not very popular, yes, they are not popular. Yes, the most popular ones are the mean, which is the most important. Yeah, the most useful. Yes, and also mode and median. They are the most popular ones. So the geometric mean and the harmonic mean is not very popular because people don't use them as much as others. But however, we will work with it now. So to obtain geometric mean, it's just for you to multiply all the values you have in a data set and find the end root of that value. For example, now, if you collect information from 10 persons and you want to find out the geometric mean of that 10 persons, what you do is to multiply the values. After multiplying them, you find the 10th root. The 10th root, I believe that one calculator can find it. Just the end root. Square root is just the two. If you are obtaining information from 2 persons, you find the square root. But if you are obtaining information from 10 persons, you find the 10th root. The next thing there is the harmonic mean. Harmonic mean is also a measure of central tendency. But the way we calculate this one is to divide n one each, multiply n of 1 over each value. For example, we have examples here anyway for each of the problems. Okay, so oh my God. Okay, we were asked to find the harmonic mean and geometric mean for the numbers 2, 4, and 8. Good. So how you find that is you multiply 2 times 4 times 8 and find the cube root. That's how you got the number. So the same thing goes to harmonic mean, which you do what? N is 3. And all over the values are 2, 4, and 8. So all over 1 over 2, 1 over 4, and 1 over 8. So once you divide that out, you have the harmonic mean. Please, next slide. You have exercise yet out with the harmonic and geometric mean. Try it out. Please, before I even forget, you can also calculate geometric and harmonic mean using Excel. The step she edit was taking, the same step can be used. Just 1 over this, 1 over this. You can work through that anyway. But let's look at another important measure. Let's look at another important measure in statistics, which is a measure of spread. It's a measure of spread. Okay. Measure of spread deals with the calculation of how far or near other values were to the central value. For example, the issue I talked about, how you can explain about, okay, the mean is mean that. The question is, if you have a mean, how do other values scatter around the mean? Okay, let's say I have the mean class performance to be 70% in the exam now. Okay, so the question should be, okay, if I have the mean to be, let's say 70% now, how were other values close or far from that mean? So it's important to know the central value. It's also important to know how scattered other values were close to the mean. For example, now, in terms of usefulness, the method that gives you the highest mean is the method someone should go with. Let's say you are trying to apply a method in your agricultural methods, and after that you try to find out the mean return for each method, try to find out the mean return. So the one that gives you a higher mean is the one that should be applied. That is the excellence in this case. The one that gives you the higher mean is the method that is the better method. So, but in terms of measure of dispersion or measure of spread, the one that gives you the least dispersion is a better approach. The one that gives you the least dispersion or the least value for dispersion is a better approach. Why? The reason is that, let's assume you make sales every day. Let's say you make sales every day, and you record what you sell. Okay, and let's say you have methods that you apply in your selling, which this method influence your sales so much. Let's say one method gives you something like this. You have some sales today. Tomorrow you have almost similar sales. Okay, and you are consistent in selling a value close to that. Okay, and let's say the other method give you like this. If you sell high today, tomorrow you will not sell at all, or you sell very small, and next tomorrow you sell very high. So in that case, there's no consistency. So the one that gives you a higher consistency is the better. That is why the one that has what? The low variability is a better method. So let's look at how the method of those methods that we use in calculating spread. We have so many methods. One of the methods is what we call the range. I think range, I don't put it here. You have range, we have interquartile range, we have a mean deviation, we have a variance, and we have standard deviation. It is the most popular. I hope someone is hearing me now.
Yes, we can hear you.
All right, so we start with mean deviation. Let's look at mean deviation, and we call this mean deviation in a shorter way anyway, but in a longer way or inappropriate way, it is called mean absolute deviation. Mean absolute deviation. It is the mean of the absolute deviation of each value from the mean. The mean of the absolute deviation of each data point from the mean is called the mean deviation. So when you are finding it, the first thing is for you to find the mean. After finding the mean, you find the absolute value of the deviation of that mean from each value. Okay? So after that, you sum it and find the mean of the entire sum.
Hello, Mr. Okobonga, are you still there? You're no longer
sure.
speaking.
Sure.
Okay.
Okay. Sorry for the short break. Like I said, that mean deviation is the mean of the absolute deviation of each data point from the mean. Okay. So the question is first, what is absolute value? What is absolute? Absolute mean the value you have, ignoring the signs. The value you have, ignoring the sign. For example, if I say 2 plus 4, 2 minus 4. 2 minus 4 should be minus 2. 4 is 2. Why? I have ignored the sign. So in absolute world, 2 minus 4 is the same thing as 4 minus 2. Okay? Right. So if you are subtracting, when you find the deviation means what? Subtracting. For example, if I say the deviation of 3 from 4, is just 4 minus 3. So that's what deviation is. So what if we say absolute deviation? We say if you find the difference, we should ignore the mean. So that's what mean deviation is all about. Finding the mean or the deviation of the data point from the mean. Ignoring what? The signs. Okay. So in this case, what we do is we have the formula here anyway, as simple as that, which is what? The sum of the absolute difference between the value and the mean, all over n. Okay. So we have an example here that says that we should find the absolute deviation from the data. And the data is 3, 6, and up to 15 and 6. Okay. So you can see what we do. The first thing is for to find mean, because we want to find the deviation from mean. So the first thing, we find the mean, okay? And the mean, we already looked at how to find mean in the previous section, okay? So in that case, you just find the mean, applying that method. After finding the mean now, you now find what? The value minus the mean and sum together, okay? So for example, now the first value is 3 and the mean is 9. So the first value should be what? The absolute value of what? 3 minus 9. Okay, 3 minus 9 should be what? Minus 6. However, because of the absolute value, what do we have? We have 6. Okay, so that is how we obtain the deviation from the mean from all the values, and then sum them up and have 36 over 11. Okay, so we see the assignment here. We have the assignment here that says that you should do this in Excel. Do this in Excel. I think it's very easy. In Excel, if you want to find absolute value in Excel, just write equal to ABS. ABS, give absolute. Okay? Yeah, so if you are using Excel, you don't have much challenge. You just write ABS. Once you put the formula, just write ABS. This cell minus this cell. Once you do that, you click, it will run through the entire cells you have. Good. So go and try that, please. Next slide. Okay. Okay. We're now going to variance and standard deviation. Like I said, variance and standard deviation are the most useful measure of dispersion. The reason is that they are very useful in so many things. For example, if you want to find standard error in testing hypothesis, they are very useful. In a normal distribution, they are very useful. So standard deviation is very useful. I should not be okay. Okay, what is standard deviation? Okay, it's almost like a mean deviation. However, this particular one has to be what? The squared deviation. So standard deviation is what? The mean of the squared deviation of the data point from the mean. I repeat, standard deviation is the mean of the squared deviation of the values in the data from the mean. Okay, you see how we explain them. So from the definition here, you understand that we are trying to look at what? How far, how close were those data points from the mean? After finding the mean, how far and how close all those other points, the deviation and the rest. So in this case, you have the formula here that we use to calculate the variance. Okay. Now, what is standard deviation? A standard deviation is the square root of the mean. Is the square root of the variance. So once you find the variance, that means you are almost finding what? Standard deviation. Just find the square root of a variance is standard deviation. Okay. All right. So let's look at an example here. We are to calculate the variance and standard deviation for the following observations. Please let me come again. In this case, we do have example here for only few values. If you are someone that is in the data processing, someone in the data analytics field, you have data. You may have data as long as 50,000 data points, even 1 million people have. So in that case, it is very certain that you will not be able to apply your manual calculation. Okay, like I've always said, you only need to understand what the theory behind what you are doing, so that as you are working with statistical tools, you understand what you are working and you can tell the whole stories properly. Okay, so in this case, you have that variance, which we call S squared, is what? 1 over n minus 1. In some cases, you can use 1 over n. And I don't need to explain that anyway. There's something you call population, and there's something you call sample in statistics. Okay, so you hear about sample mean, sample standard deviation, sample variance, and you also hear about population mean, population standard deviation, population variance. Okay, so what the meaning is that we use the one in the sample to estimate the one in the population. For example, if I am calculating sample variance, that means the sample variance can be used as an estimate for the population variance. So because we are estimating, that's why we subtract 1 minus n. If you are calculating population variance, you use what? 1 over n. Please take note. Take note. So what I'm doing here is what? I'm calculating what? Sample variance. That means I'm calculating variance from information that I obtained from a sample. A sample is a fraction of the population, not the entire population. So because I am calculating something that will be used to estimate population, we subtract what? The entire n. We subtract 1 from the entire n. That's why you see over n minus 1. So if you are some other textbook, or some other persons may just ignore and use 1 over n, and it wouldn't change anything. So have that idea now that this is for what? Sample variance. Okay. Okay, so this table now is a calculation of those parameters. Okay, so this table, we just put the data set first. You see x at this data, it was minus 10335. So you see them all there. So the next thing is to find the deviation from the mean. So after finding mean, the deviation mean what? The value minus mean. So subtract mean from each value and square them. Subtract mean from each value and square them. After squaring them, sum them through. After summing them, take the result and divide by what? N minus 1. If you are calculating for sample. If you are calculating for this thing for population, just divide by n, and that ends it. For standard deviation, you don't have any other work to do than to find square roots, and that gives you the value of standard deviation. Okay. All right. We have assignment here that you should do this in Excel, following the illustration above. Okay. Good enough. You can use Excel. You can use Excel. Okay. Next slide, please. Okay, there's an exercise here. The exercise here. All right. And before I leave this page to another page now. There is also a way you can find those things without going through the calculation. In short, the calculation you are doing there, it's also like a manual process because you are calculating bit by bit. Apart from that, in that Excel, there is a function that is called standard deviation. There's a function that is mean. There's a function that's median. For example, now, if you type in the entire values in the Excel, just write equals to MED. Equal to MED. As you write MED, you see median comes out. So median is there in Excel. And again, if you want to find standard deviation, after typing the entire values, just highlight the entire value and write equal to STD. You see standard deviation will come in. Okay, good. Apart from that, if you are analyzing using Excel, once you put in your entire data set, just go to I think the panel that display so many information. You will see what we call data. Click on data. As you click on data, some other thing will open. You will see you will see data analysis. Yes, you will see analysis, data analysis. Click on analysis. You will see different methods and statistics coming in. You will see regression, you will see correlation, you will see standard deviation coming in. So you pick any of them if you want, any of them. Just pick any of them you analyze. Okay? I don't know if there will be any class that centers on using Excel for statistics. I would have loved to take that because there are so many functions in Excel that we use to do analysis. Some of these things we mentioned, you can analyze them with a click, not until you go through calculation process. Yes, there are some functions that run the entire matter without you adding or subtracting. Okay. So if someone is listening to me now, please type go ahead or continue.
No, I don't take questions.
Please,
I want to see go ahead.
I can hear you. And as
Okay,
far as for your last comment, yes, of course, this is first semester and it's just introductions, right? So second semester is coming where we go deeper and all that into statistics. So yes, we'll be glad to have you handle that.
Okay, all right.
All right.
Okay, yeah, we go to a different aspect, random variable and probability. Random variable and probability are this particular area is very interesting also. Random variable and probability. Probability is a way of working with uncertainty. And did I even mention that I think is a science of uncertainty? Please, if I did not mention it very well, it's not uncertainty. We work with statistics whenever we think about something that is not clear. Let's say you are imagining how your business can work next month. So it's not clear. The factors surrounding business in every day is so uncertain. So in that case, we use the idea of statistics to estimate it. So an area that work with what you finding the likelihood, you finding the chance of something exciting is what we call probability. Probability, a science of chance, or a mathematics of chance or uncertainty is probability. And one of the things we have here is random variable. Random variable. Okay. All right. Before we explain, the first thing we call it random experiments. Random experiments. In short, random means what? Something that is not fixed. It's not fixed. It varies anyhow. Yeah, you got something that is not fixed. You don't just understand it. It occurs just by chance. Those are the random things. So if I'm talking about random experiment, it's a kind of experiment that you do not understand the result before. Okay, you don't know the result before the experiment is done. And conducting the experiment on that same process will give you a different result. So we call that random experiment. An experiment that's different from the experiment you have in physics and chemistry. Remember in chemistry, if you are doing titration in chemistry, add one more of this, add two more of that. As long as you add that thing effectively, they already know the result. If the result is to turn out pale blue, and your own work, it turned out something else, that means you are wrong in the process, and that is sure, because the experiment is not random. You're supposed to come out with the same result. Apart from that, we have a different experiment. We use statistics here. We call it random experiment. An experiment that even if you do it with all amount of carefulness and obeying all the instruction, the result still come out different. And in that case, you don't have idea about which result will come. Okay, you may project, you may have you may have a list of possible outcomes that may occur, but which one will occur, you don't know. We call that what? A statistical experiment or random experiment. Example, the draw of a coin. Let's say you want to, let's say they want to start match, and you are the one officiating, and you want to pick the one that will start. And you don't want to be biased. In that case, you pick a random experiment, which is a draw of a coin. You know that the two sides of a coin, anyone can occur. But do you control it? No. Which one will come out? You don't know. We call that a random experiment. Another experiment in that class is, let's say you throw a coin. For example, now you throw a coin. Sorry, let me say a die, a Ludo. You like play Ludo, okay? If you throw it, it has 6 faces, okay? You want to toss it now. Do you know which one will come out? Never. Never. And you tossing it 10 times doesn't mean that its same value will come out. It keeps changing. So such experiments is called what? Random experiments. Random experiment. Now the next thing, what we call sample space. Sample space is what? The list of the possible outcome of that experiment is called sample space. For example, in a toss of a die, you are sure that one of these sides will come out. Yes. So in the Ludo game now, Ludo has how many faces? 6. 1, 2, 3, 4, 5, 6. So the sample space is what? 6. Okay. A coin has 2 faces, head and a tail. So the two sample space is 2. So the list of possible outcomes of a random experiment is what we call what? The sample space. So the next thing what we look at is what we call the event. Event. What is an event? Event is what? A subset of a sample space. A subset of a sample space that you may be interested in. For example, now, let's say that you throw a coin, and that let's say that you throw a coin, and that if you have the head turning up, you call it success or you win. So head alone is what? A subset of that sample space. Okay? Yeah. So in the list of let's say the list of the faces of 1, 2, 3, or 5 of the coin, sorry, of a die. So 1, 3, which is a subset of that sample space, is what we call what? An event. Event. Okay. All right. So now, what is a random variable? A random variable is what? I call it a real value function that is made on a sample space. A real value function assigned to the outcome of a random experiment. What we call what? A random variable. Okay. So we use capital letters to denote random variables. Capital letters denote random variables. For example, X, Y, capital letters denote random variables. For example, now let's say you are tossing a coin. You are tossing a coin. Let's say you're tossing a coin. So it may come out head or tail. It may come out head or tail. Okay. And if you toss 2 coins together, it will come out either head tail, or tail tail. Now, if you assign values to this head or tail, it becomes what? A random variable. Become a random variable. Okay, I think we have an example. Okay, example, you have an example here that says that example here say that you should consider an experiment of throwing a coin 3 times, and then that you should construct the sample space and also the random variable for the number of heads that appear. Very good. I think this one will bring a kind of a big clue about what random variable is. So we already talked about what sample space is. So if I throw a coin 3 times, okay, so these are the possible sample space. You will see it can be head, head, head. It can be head, head, tail. Head, head, head mean what? That the first coin appear head. Second coin appear head. Third coin appear head. Okay. If you are talking about head, that means the first row is head, second row head, third row tail. So same process can be used to analyze the remaining. Okay, so at the end, you have these possible outcomes that can come out. There's no other possible outcome that can come out again apart from this. Good. So if you count them, you have 8. You have 8 possible outcomes that can come out. Okay. So each of these 8, okay, all of these 8 consider what we call the cardinality. So the cardinal of sample space is what? 8. Cardinality means what? The total number of what? Elements in a set. So if you count this element now, they are what? 8. So the cardinality of sample space is what? 8. Please, the next page. Next page. Can someone hear me?
Go on the next page, please.
All right, so next page is where we put down the random variable, the table of the random variable now. So the other page, we were only putting down the needed sample space. Now, I said that a random variable is what? A real value function defined on a random experiment. That means translating those outcome of experiment to real values or to numbers. So a function that assigns numbers to outcome of experiment is what we call what? Random variable. Now let's look at how the numbers come. The question was that we are interested in what? Counting the number of heads that turn out. Please, after go and check the question. The question is that you should construct what? The number of heads that come out. So if you look at the set of possible outcome now, how many heads do we have per the event? You say the one that has head, that means what happened? It has 3 heads, right? Good. The one that has head, tail, that means what happened? 1 head, 2 tails. The one that has head, tail, that's head, HTH, has what? 2 head, 1 tail. So you can have that knowledge of analysis. So what happened here is, you will see here X denoting what? The random variable. I think I've said let X denote the random variable. Okay, let X denote the random variable. So that means if you were interested to form random variable for outcome head, you should do what? You should count the number of head per a subset. So the subset that has to be tail has how many heads? 0. That's why you see here X. The next column you see 0. And favorable case, which case produced that? It was tail. I put that favorable case for people that are starting newly to understand. If I was the one who only put X 0, 1, 2, 3 and go my way, because this favorable case is for you to understand which process brought up that number variable. So the next one is 1. Which case is bring the number of heads to be 1? Is HTT, THT, and TT head. Okay. The next other thing you can get is 2 heads. 2 heads. So 2 heads. Which case is brought 2 heads? If you look at the list of that possible outcome, the sample space, you will see that after displaying all those things, I now selected these things out depending on how they are reflected, the number of they produce number of heads. So the one that produce 2 heads is what? They are these HTH and the rest. Which other one produces how many 3 heads? Is only HHH. So we call this what? A random variable. A random variable. A function that assigns real values to the outcome of a random experiment. We call that what? Random variable. So there is an exercise here. The exercise here says what? That you should consider an experiment of throwing 2 dice together and then determine the sample space for the experiment and then construct a random variables for the number of odd numbers that turn up. Please let me just break this exercise down for some of you that want to spend time to do the exercise. Please give me some. Okay, sorry about the break. Okay, so for those of you that want to do the this exercise now, I believe only people will do it. What this thing means is that you should consider throwing a die. A die has how many faces? 2. Okay. Now, if you throw them together, their faces will multiply. 2 here will multiply and become 6 and become 36. Now, you look at the possible combinations of the faces that turn up. It can be 1 1, 1 2, 1 3, 1 4, 1 5, 1 6, 2 1, 2 2. So after the possible combination now, that means you have drawn a sample space. All the possible combination is what we call the sample space. Okay, good. So after that, now the next thing is to define a random variable that has to do with the number of odd numbers. So now, out of the two numbers that come out, we know the meaning of odd number. A number that is divided by 2 and has remainders. Is that how it is done? Yes. So a number divided by 2 and you have remainders is odd number. Yes. And the one you divide by 2 without remainder is the number of odd numbers that show up. That means if you have 1 1, the odd numbers are what? 2. Okay. Yeah. So the one that is 1 1. 1 1 is what? 2 odd numbers. That means the odd number should be 2. The one that is 1 and 4 is what? 1 odd number, 1 even. So if you're counting in that particular event, that means you have one odd number. So use that to create a random variable for the number of odd the number of odd numbers that turn up. Okay. All right. Please, we go to something else. The type of random variables. Random variables can be odd. Can be discrete, and it can also be continuous. Random variable can be odd. Oh, please, sorry for that break. So random variables can be divided into 2 parts. Discrete random variables and the continuous random variables. The discrete random variables are the variables that take on values that are countable. Any random variables that take on the values that are countable is what we call the discrete random variables. Whereas a random variable that take up values in the intervals are what we call the continuous random variable. Let me explain. What do you mean by countable numbers? For example, 0, 1, 2, 3, 4. If a random variable takes the random variable we formed previously is what? Discrete. The number of heads is discrete. Okay? Yes, it's discrete. If you are forming random variables, or let's say the number of persons per family, that is what? Discrete, because number of persons can be what? 1, 2, 3, 4. But if you are forming random variables on let's say the weight of individuals, weight is what? 0 point something. Any value that is 0 point something, 0 point something, 5 point something is what? It takes what value what in the interval. So those are what continuous. Something like temperature, something like weight of individual, they are what? Continuous. So take note of the differences between the two. The discrete and the continuous. And okay, the next thing we want to define here is probability. The concept of probability. Like I've explained earlier, probability is a mathematics that enables us to calculate or to talk about chances or likelihood of events occurring. A mathematics, a branch of mathematics that deals with what? The science of chances, the likelihood of the occurrence of events is known as probability. All right, so we have some rules associated with the calculation of probability. So probability has some axioms, some rules that shape our calculation. For example, if you should understand that the value of a probability can lie between 0 . Okay, I'm sorry for the break. Hello, can you go back? Can you go back more? Just go back. Okay, and so probability, we have, like I said, we have some rules, some axioms that enable us to calculate probability or that shape our calculation in probability. For example, if you are calculating probability, you don't have to get a value of probability to be more than 1. So if you are calculating and at the end you have the value probability equal to like 1.5, even 1.1, you are wrong. You need to go back and check the process. Okay, and also you don't need to have the value of probability to be negative. So a probability value lies between 0 and 1. And if a probability value gives you 1, that means that event is termed a sure event. A sure event. Okay? So a sure event gives you probability 1. For those individuals that say that they are very sure that thing will happen, good. So if you are so sure that an event will occur, that means that thing has what? Probability 1. Probability 1. Okay? And the probability of a null event you are sure will not, it has what? Probability what? 0. 0. So we call that an impossible event. So if there is an event that is impossible, we call that what? Impossible event. So that event has probability what? 0. Good. So these are like boundaries of probability. Is that it's impossible or you are sure? Apart from that, any value that's intermediate, any value within 0 point something. So it's what? A chance. So in that case, you don't need what? Negative probability, and you don't have probability that is what? That's more than 1. So take note of that. Okay, so we have here a classical way of calculating probability. A classical way of calculating probability. Okay, we have a classical way to calculate probability, and that classical way says what? that probability of an event E, let's say you are interested in doing probability of events, let's see that event is E. So that probability of event E equals what? The number of possible cases to E all over the total number of possible outcomes. So for example now, these sample space that I wrote down and I write probable cases, if I want to calculate probability of event that has a of event having one as this ground variable, that means we what? How many is here? 1, 2, 3 over 8. I repeat. I say for example now, in the set of random variable that I write down that we found earlier now, if I am interested in calculating a probability that the random variable x take up the value 1, that means the number of probable cases is what? 1, 2, 3. That is HTT, THT, and TH. So number of probable cases is what? 3. And what is the number of possible outcome? You count all the cases here, which is 8. So the probability of that event and of that number variable taking on value 1 is what? 3 over 8. That is it. So we apply this formula, this classical formula to calculate probability. The number of probable cases, all by what? Total possible cases. Please, next page. Okay, we have example here. Example says that a fair die with faces number 1 to 6 is rolled once. That should write down the sample space and then find the probability that the score showing up is a multiple of 3 and B is a prime number. And that is a very simple case, a very simple calculation. A very simple calculation. So the first thing is to do what? To write down a sample space. The sample space for this matter, for this experiment is what? 1 to 6. 1, 2, 3, 4, 5, 6. So the sample space is what? 1, 2, 3, 4, 5, 6. Among these, we are interested in the event of what? The number is prime number, and also in the event that the number is what? Is a, let me check the question again, is a multiple of 3. So after writing out the sample space, you look at which one are prime number. So out of 1 to 6, the prime numbers are what? 2, 3, and 5. You see, the event of prime numbers has this what? Set 2, 3, and 5. And also, those that are multiple of 3 are what? 6 and 3 only. Good. So therefore, the probability of multiple of 3 is what? 2 over 6. Why? Because the cases favorable to that experiment, favorable to that subset is what? Only 2. And the entire cases is what? 6. So that is it. That's how we apply it. And the same thing happened to the second example. And we have a size here. The size says what? That together, what is the chance of having at least a hit? Please, I really wish the students can work this exercise, and then we assess how they understand. Please, this is a common, a very common and simple exercise that someone can do it within a few minutes. So please inform the student to try and do it.
All right, that's fine. Please take the exercises that we've had so far, take them seriously. We would share the presentation slide, of course, and that would give you, we share with you the email address where you would email your answers or your work for assessment. Okay, please go ahead.
Okay, let's go. Let's go ahead. Okay, we have apart from the ones we have here, we have something we call compound event. Compound events. Let me come again. These ones are simple events. Why are they simple events? Because they are events that take a simple, just a single random variable at a go. Okay, so we call that a simple event. Good. Apart from that, we have what we call a compound event. Event that take up two or more, event that take up two or more cases together. Okay, so we have to treat that in the next this thing slide. Okay, so please next slide. Okay, so we have a compound event. All right, so when we have a combination of two or more events together, we call that a compound event. For example, event A and B. If you are taking up two events, for example, now the event of selling okay, for example, an event of picking a ball from a basket, and also the event that the ball is black. There are two events now. You see, there are two events. For example, the event of selling your television, and also the event that the television was sold to someone from this region. So all those things are a compound event, something that takes two or more events together now. Now, in dealing with compound events, there are things we define. There are some terms we take into consideration which affect the calculation. One of them things what we call the independent event and dependent event. Dependent and dependent events. Okay, and when do we say that two events are dependent? When do we say that two events are independent? Okay, an event, okay, two events are said to be independent if the occurrence or non-occurrence of one does not influence the occurrence of the other. I repeat, an event, okay, two events are said to be independent if the occurrence or the happening of one does not influence the happening or non-happening of the other. An example is like this. Let's assume that we are in a political party and we have different candidates coming from different regions of the country. For example, let's say the PDP now. PDP having a candidate from Akwa Ibom, having a candidate from Adamawa State. Very good. Very good. So these are independent candidates. For example, let's say the candidate in Adamawa State fighting for the post of a governor, and there's also a candidate from PDP. So an event of someone from Adamawa winning the election does not depend or does not influence the event of someone from Akwa Ibom State winning that governor's election. So we say that the event A and B in that case is what? Independent events. Hope that's clear. Good. However, if at all the happening of one influences the happening of the other, we call that a dependent event. Please take note. I don't know if someone can think about a case of dependent events here. A case in which one depends on the other. Okay, for example, let me think about the sale of products. I think I do look at the thing about some products that are being sold in the market. Some depend on other. For example, now I do see people that sell corn and pear, very good. Corn and pear, very good. Corn and pear. You see, some people, just like me, some people do not like eating pear alone. So if you are selling pear alone, you are just selling it. I will not eat it. But if you are selling corn and pear, me buying pear influencing me what? Buying corn. So the event of selling pear and the event of selling corn are what? Dependent. They are dependent. So there are cases like that. So there are so many cases like that dependent. There are some that are independent. So we go to another one now. Okay. Apart from that, we have another kind of event that we call the mutually exclusive event, or non-mutually exclusive event. Okay. Two events are said to be mutually exclusive if they can occur at the same time, or if they can occur, if they cannot occur at the same time. I repeat, two events, A and B, are said to be mutually exclusive if they cannot occur simultaneously, or if the happening of A precludes the happening of B. So we call that mutually exclusive. But if they can occur together, we call that what? Non-mutually exclusive. For example, the event of me delivering live class and the event of me reaching in my class, reaching in my church now is what? Mutually exclusive. You can't see me there now because I'm having my time here. So there are two mutually exclusive events. So if you think of events that cannot happen together, so if someone talks about seeing me, if someone talks about seeing me in the market now, that means automatically that I'm not supposed to be here, I'm not here anyway. So in that case, they are what? Two mutually exclusive events. All right, so there are mathematical principles that are that are available as a result of those events. For example, now in set we know about the union of two events, A and B. Good. So in that case, if we are defining those events to be mutually exclusive, there are ways we calculate them. For example, if you are calculating two mutually exclusive events and you are finding the union of those events, the probability of the union of two events that are mutually exclusive should be what? Probability of A and probability of B. And take note, we are just talking here based on two events. Remember, compound events can be as much as 3, 4, 5, 6, 7, 8, 9, 10 events together. So we are just using example based on what? Two events only. It can be 3, it can be 4. And the principle guiding 2 is the same principle that guides 3, 4, 5. So for example now, if I say the probability of the union of 3 mutually exclusive events should be what? Probability of A plus probability of B plus probability of C. If they are what? Mutually exclusive. Okay? But if there are two events that are mutually exclusive, it should be what? Probability of A plus probability of B. Something happened to the independence of events. For example, if I want to find the probability that 3 events occur together, and these events are independent events, that means what I'm to find is what? To find the product of their respective probabilities. That will be the answer. Okay? So that is it. Next page, please.
Boma, the next
page.
Boma, are you there?
Okay, we now look at the conditional probability of two events. Very good. I think at this stage, we talk about two events. I think what guided me was the curriculum that was sent to me. Yeah, it guides me a lot. So at this stage, it's two events. That is why I keep talking about two events. So let's look at what we mean by conditional probability. What mean by conditional probability? A conditional probability is a probability that respects the probability of another event. Okay. For example, now, some may say the probability that event A occur given that B has already occurred. So in that case, the probability of that current event is conditioned on what? The occurrence of the other events. Okay? All right, so the probability of events given B is then what? The conditional probability. And this is the probability of the occurrence of what? Event A when another event B has already occurred. So the probability you calculate with the knowledge or with the assumption that another one that relates to the current one has already been occurred or has already occurred is what we call what? The conditional probability. The slash that we put here is called what? Given. So if I say P of A slash B, I'm talking about what? Probability of A given B. Meaning what? I'm finding the probability that event A will occur given that B has already occurred, or conditioning on the fact that B has already occurred. Okay, so we calculate that using the expression or using the formula that is equal to what? The probability that A and B occur together, or our probability of B. Okay, so if you see intersection in probability, it means what? That they occur together. If I say probability of A intersection B intersection C, that means I'm saying that the probability of the joint occurrence of the three events A, B, and C. Please take note. Take note. All right. Okay, so we look at the probability distribution. Probability distributions. Okay. All right. Probability distributions are progresses from random variables and how they distribute with those favorable cases. So a probability distribution is a function that enables us to find out how a random variable takes up their values with their respective probabilities. A function which assigns probability values to each value of the random variable is called probability distribution. Okay, and we work that out on the basis of the random variables and the associated favorable cases. For example, now let's look at the example that says that we should determine the probability distribution of the number of hits that occur in a simultaneous throw of 3 coins. This example is a part of the example I presented earlier concerning sample space. Okay, so like I said, we work with favorable cases whenever the issue of probability comes out. And a function that shows how the value of the random variable takes up some probabilities is what we call what? Probability distribution. Okay, let's solve this particular example now. That says that we should find out what? The probability distribution for the number of hits that occur in a throw of 3 coins. Okay, and we are also asked to find out the probability of obtaining at most 2 hits from that distribution. All right, in solution here, please, if you are working with probability, or yes, if you are working with probability, please be used to this. I think this particular thing is so important that because it tells the examiner that the person understands what he's doing. If you are asked to find out the probability of any event, or the probability concerning what random variable, please learn to do this. Learn to say, let X denote the random variable. Let something denote something so that you can use that particular thing to find the probability. And that gives a clear understanding that you know what you do. Okay, so let's look at the solution now. The solution said that we let X to denote what the random variables. And depending on, or according to what we have calculated earlier, that the values of the random variable is what was 0, 1, 2, 3. Remember, we have done that already. Yes, we have done that already now. So forming the probability distribution here is possible how these random variables 0, 1, 2, 3 takes up the probabilities. Okay, and how do you do this now? We put down the sample space again here, and we have also put down the total number of sample space, which is 8 now. Okay, and remember that the favorable cases to the value 0 was 1. Okay, and according to the classical probability technique we put down, number of favorable cases, all of our total number of possible cases, we apply that technique and have probability what? 1/8 under 0. And same technique, if you count the favorable cases, so event of x taking value 1, it was 3. So that's how under 1 we have what? Probability 3/8. So a combination of these x values and the probabilities is what we call probability distribution. Hope that is clear. So a function or a table that shows how the probability was distributed across the possible values of the random variable is what we call what? Probability distribution. So we go to part B. Part B says what? That we should find the probability of obtaining at least, okay, at most 2 heads. You should find the probability of obtaining at most 2 heads. Okay, now, what do we mean by at most? At most mean what? That you have nothing more than that value. Okay, at most 2 heads is mean the probability of having 2 heads down. Okay, so we have 0 head, 1 head, 2 head, and 3 heads. So at most is what? At most 2 is what? 0, 1, 2. Okay, that is why the probability of having at most 2 heads is the probability of what? Having less than or equal to 2. And is equal to what? Probability of having 0 plus probability of having 1 plus probability of having 2. So because we are talking about mutually exclusive events, that is why we do what? We have to sum the probabilities. So summing the probabilities is what? 1/8 plus 3/8 plus 3/8, and that gives us 8 as answer. Please, next, please. Next slide. Is someone hearing me here? Hello? Okay, I believe someone is listening. Now we now go into what we call the mathematical expectation. Mathematical expectation. Another name for mathematical expectation is mean value or average value. Remember, the way we calculated mean in the previous pages is to sum the entire data set and then divide by the total number of values we have. And what enabled us to find the mean like that was because we have the values of data set. But the question is, how do you find the mean if you don't have the value or if you have only the probabilities? So a way or a technique that enables us to find the average or the mean value of a random variable when only the probabilities and the values of the random variables are given is what we call what? The mathematical expectation. Take note. We must have treated the way we find mean when data are given. Yes, that one we have data. But in this case, we only have what? We only have the probabilities and the values of the random variable. Remember, we do not have data. The random variable does not mean data. It's just what? A real number associated with what? The random variable. So in this case, we don't. So in this case, finding the mean value is different from finding the mean value of the other mean. So how do we find the mean value here? For discrete random variable, we find expected value as the sum of the value of the random variables multiplied by the probabilities. So if you multiply probability by the value of random variable and sum them through, we call that the expected value. And we denote that by EX. By EX. However, if it is a continuous random variable, remember we've treated two types of random variable here, the continuous and the discrete. For continuous, we think about integration, because in continuous we have what? Everything is what? It's an interval. So there's no way you can sum a continuous information. You do what? You integrate to find the aggregate of the information. So in that case, what do? We find the integral of x multiplied by f of x. F of x is what? The function that gives that probability. Okay? So for discrete, we have what? We sum, and for continuous, we do what? We integrate. Okay, so let's look at this example now that says that we should find the expected value of x if the probability distribution of x is given in the table below. Okay. All right, we have x, 0, 1, 2, 3, and this. Now, one could ask, is this table for a discrete random variable or for a continuous random variable? I will not wait for someone to answer that. I will just tell us how to spot that the thing is for discrete, please. So the question here is for us to find the expected value. But the issue of whether it is discretable or non-discretable is not mentioned. However, you can just spot that you can just identify that by seeing it. How did we define discrete random variable? We say this random variable what? The random variable that take on what? Values that are countable values. And we say for continuous, the values are what? In the interval. So if you look at this, you will see that x take on value 0, 1, 2, 3. In that case, 1, 0, 1, 2 are those what? Countable numbers. So it's what? Discrete. Please take note. Take note. Whenever you see a random variable x and the values are 0, 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, 4, 5, they are all countable. So in that case, you apply discrete technique. Okay. So finding the mean here is to do what? Apply that formula we have. That is what? Sum of x, probability of x. Okay. So we have here x and the probabilities. So to find the expected value, we say, okay, 0 multiplied by 1 over 8 plus 1 multiplied by. So you multiply the value of the random variables by the respective probability and then sum them through. And you have the results of being the expected value. So in this case, we do the same thing. Okay. And then you have exercise here too, which I will advise everyone to try. Yes, everyone should try this exercise that say that you should calculate expected value of x and the expected value of x squared if x has a PMF that is given in a table below. So try and work that out. This particular manual, this particular slide is very self-explanatory. You can walk through other examples and see how they are being calculated and then apply the technique in the exercises. Okay, please, next page.
Next page, Boma.
Subtract the power of denominator from the power of numerator. I raise it to that page. So,
Boma, are you there?
Power p divided by a raised to power q. If you check that, the same value is within different powers. Is in
Okay, all right. We now go into correlation and regression. I think this should be the last slide. Okay, the last topic, correlation and regression. And please let me just emphasize this here. Each of these concepts we are treating, they are broad. We just try to confine ourselves to the time limit. It's something that can be taken all over the entire semester. Yes, all over the entire semester. Because something like probability alone can take you like a whole day, a whole class, a whole day of the class. Yes. Sometimes it can take even 2 to 3 days, depending on how deep the curriculum is. Yeah. Same thing goes to this correlation regression. Correlation regression is a very large, broad concept. Someone can just, we can just take this in the entire class day, in short, even 2 days, for this particular topic alone. But however, we are just trying to brief you on how it is done so that you can kick up your understanding from here. Yes, you just want to give you some brief foundation. Okay. Now let's explain the meaning of correlation regression. Okay. Everything we mentioned earlier, we talked about univariate cases. What do you mean by univariate case? A case that has only one variable. A case that has only one variable. For example, now, if you want to talk about the income of individual, so that variable should be what? Income. Income. So a data you obtain from that is what? Concerning the case, average income is what you obtain. In that case, your analysis takes into consideration what? A single variable. In that case, talk about what? A univariate case. Yes. But the concept of correlation is different. Correlation and regression is different. Because we talk, in this case, we deal with what? Bivariate case, a case of double variables on there. And why is this so? Correlation deals with what? The level of relationship that occur between two variables is what we call correlation. The degree and the nature of relationship of association between two variables. So just imagine that we talk about what? Two variables. Now that means we are talking about bivariate cases, a case that one variable has to be used as a measure of another variable. For example, someone will want to look at how income level affect buying attitudes of the people. How income level influences or associated with what? Buying attitude of the people. Yes, someone will also want to find out how the level of education affect crime in a community. In that case, you enter a community and look at the academic level of the people in the community, and then try to count also the crime scene in the community, and then you can do an analysis and look at the level of association, whether an increase in education causes increase in crime, or whether an increase in education causes decrease in crime. So in that case, we are talking about what? Correlation, the degree and the nature of relationship that exists between two or more variables is what we call correlation. Okay, we have types of correlation. So I can as well say type of a relationship. Okay, good. So we have different types of relationship, but the most popular ones are, we have positive relationship, we have the negative, and we have the zero relationship. Okay, so what is positive correlation? Okay, if the changes of one variable causes the change in another variable in the same direction, we say that both the variables have positive relationship. For example, if an increase in the value of one variable causes an increase in the value of the other variable, we say that there occur or there exists a positive correlation or relationship between the variable X and Y. For example, I talk about the crime scenes in a society now. So if you enter the society and take your statistics and you obtain information about the level of education there, and then try to count the crime cases in the community, good. If an increase in education level causes an increase in crime scene or in crime cases, that means what? That means in that community, that academic academic achievement or academic attainment and crime case are what? Positively correlated. So in the other aspect, or in other type of relationship, I mean the negative relationship here, it means that an increase in one variable causes a decrease in the other variable. Okay, this is unlike the positive relationship, which an increase causes increase on the other one, and if a decrease causes a two-way thing. An increase causes an increase or a decrease causes a decrease. But in this case, it's a reverse case. So for negative relationship or negative correlation, what happened? An increase in one variable causes what? A decrease in the other one. Okay. For example, in the crime case I'm talking about now, if you enter a society and you see that as the number of graduates, the number of people in school increase, the crime cases decrease. That means crime cases and academics have negative relationship. That should be that's clear enough. The next type is what we call the no correlation or zero relationship. That means yes, that it means that the level of changes in one variable does not influence the level of changes in the other variable. Okay, good. So then, how do we understand this? I talked about if you enter a place and you obtain data. Okay, the analysis of this, it has its own part of analysis. Okay, so then what about how we study them? How do we analyze its own data now? So we have a way of studying them. Okay, we have two ways. One way is the use of graphical method, or we call that scatter plot or scatter diagram. Another one is the use of what? Correlation coefficient. Okay, so you can study the level and degree of relationship using what? Scatter plot, or you can study using what? Correlation coefficient. Okay, so let's first look at scatter plot. Like I said, a scatter plot or scatter diagram is a graphical method of studying relationship. We have a way of plotting that using we have this in some ways, even in Excel, we have correlation in Excel that help us to work on scatter plot. So please, we're still talking about scatter plot. I want to finish scatter plot, please. Go back. Please go back to scatter plot. We want to look at how the scatter plot. So scatter plot is like this. After plotting the point on a graph, how can you identify that yes, what happened between them is positive, or it was negative, or it was no relationship? Now look at how it works. If you plot a scatter plot and you see an upward movement, good. Like the phase diagram here, diagram A, is what? An example or a graph of a positive correlation. Why? Because you see we have an upward trend. Yes, an upward trend, an upward direction of the points on data. So this dot point is the value of the plot. This line is just a line you just draw to show clearly that was an upward trend. Okay, so in that case, an increase in X variable causes an increase in Y variable. So we call that a positive relationship. So B, feature B is a clear example of negative. You see a downward trend, a negative slope. Okay, it comes from the top left, and I go down to the bottom right. So in that case, it's a 4. It's a 4. That means as one variable rises up, the other one falls down. So in that case, they have a negative relationship now. So we go to C. C is also a negative. However, it's a kind of curve. It wasn't as straight. It wasn't as straight and direct as the other ones. Although it was a negative relationship, it was a kind of a zigzag movement. It wasn't straight at once. It was a kind of curve. Now the D is what? An example of no relationship. You see, there's no pattern. It doesn't form any pattern. It just cluster around. The data point does not form any pattern. It just scatter around. So in that case, there's a zero relationship. Please go down. Let's look at another technique. Next page. All right. So the next method we use in identifying the nature and the degree of relationship is correlation coefficient. Okay, this particular one is a calculation that gives us a value. It's a calculation that gives us a value. So unlike the other aspect that we plot calculation and for analysis immediately. So, and how do we analyze, and how do we conclude, and how do you interpret? Okay, so analysis will give you the value, like I said. It's you and your understanding that will write the story about what you saw as the value that came out from the laptop or the system, if you are using system. So if you're analyzing the process or the data on correlation using a laptop, even if you are using a manual calculation now, the value that will come out will be between 1 and -1. Please take note, in correlation analysis, the value of the coefficient is what? -1 and 1. Like it's between -1 and 1. So that if you have -1.5, you were wrong, go back to calculation. And you have 1.2 is wrong, go back to calculation. The value must lie between what? -1 and 1. It can be -0.9, -0.2, -0.3, -1, -0.5, -0.8. As long as you reach 1 in both ends, both negative and positive, you've ended. Okay, let's look at how we can interpret that. If you calculate and you find out that the value of R, I mean the value of correlation coefficient, we denote it by R, or some people use the rho, but you're using R in this case. So let's say you calculate and you have that the value is 1. That means there's what? There's a perfect relationship between them. A perfect means what? A unit increase in one cause what? A unit increase on the other. Okay. So, but if the value is -1, we also have a perfect relationship. But in this case, you have a perfect negative relation that you have and the 0. Okay. So it can be strongly negative, it can be really negative. So if you have 1, that means what? Perfect. It has reached perfection from any end, either negative or positive. Now let's look at that. Let's look at if you have like -0.2. You see, it's negative. Now, negative symbolizes what? That the nature is what? Negative. But 0.2 is what? Talks about what? The strength. The value of the coefficient talk about what? The strength. Why the negative talk about what? The direction. Okay, that means 0.2 is what? It's weak. It's not up to. From 0.5 up should be strong. So value from 0.1, 0.2, 0.3 should be somehow weak. So from 0.5 up is strong. 0.9 very strong. Okay. So in this case, if you have -0.2, you have what? That the how we interpret that they think they have what? Weak and negative. If you have 0.8, you have what? Strong and positive. But you have 0, what do we have here? No relationship. So if you analyze data based on correlation coefficient and you see that the value of R is what? 0, just conclude that what happened? That there was no any relationship between them. Okay. All right. So the concept and principles we use to calculate R. Okay. We have something like a Sparman rank correlation coefficient. And also what we call the Poisson product moment correlation coefficient. Okay, so we have those two. The one we want to apply now is what? We want to apply the Pearson product moment coefficient. Okay, so this is how we calculate them. The formula, although look like something very big, anyway, it's not big. We used to use manual way to calculate this. Yeah, you can use Excel to run those multiplication. And also you can use Excel to run the entire analysis without putting the formula. But understand this, that whatever you are doing, what an Excel or a software understand is, or the process that the software goes through is what we write down here. So you understand the theory so that you understand how you can interpret. Okay, so we call this the correlation coefficient between variable X and Y using the Pearson product moment correlation coefficient. That given the pair of value X and Y, which goes x1, y1, x2, y2, up till x1, y, x, and yn. I've already talked about what x is r, okay? This one, we just added y, meaning that it's the value from the other variable, all right? So that the correlation coefficient is given by this formula now, okay? Please, next page, let's look at an example. Okay, we have an example here that says that we should determine the coefficient of correlation for the set of data below. Okay, the data was concerned the weight and blood pressure of somebody. I think this data was a live data. It was a data that was collected for a purpose. Like I said, if we are just suggesting, no problem, good. It might be as we are suggesting data, or we are just using data, for example. But the real thing is, this has its own use in real from a real life data. Someone collected want to determine if the blood pressure of an individual affects the weight, maybe or vice versa, if they have relationship. So someone wanted to find out if blood pressure can influence the weight of an individual. So you as well, you can find out something like this. You can just check whether the income of parents can affect student performance. Yeah, in your classes, we used to check something like that. Yeah, sometimes you may read some books and you see what someone say affirmatively. You don't understand where the person has gone through this. Yeah, you can go on the street and tell someone that, look, as richer, okay, you can say someone, look, the richer and the is in class, the less serious he is in class. Why? Because you've undergone some study on this, collect data now, try to analyze, and it shows you evidence. So you have an evidence-based decision. You have to speak tough, that you know what they're talking about. So something like this now, someone wanted to understand whether blood pressure is related to what? The weight of an individual. Good. After this now, you see the result. Okay, for example, now, we have done the calculation based on the Pearson moment correlation coefficient. And we found out that the result is what? 0.5966. And from what we had earlier, I strongly believe you know how to interpret this. I will not say how to interpret this now. How you can tell someone that, okay, look at what happened between blood pressure and the weight of individual. Okay. So if you use this formula now, you can just slot in this and have your result. Okay, I think I've seen a sign here that it has a clip on how to help us calculate this using Excel. Please, can you take over? Edit?
Yes, please. Okay, Buma, you can stop sharing.
Okay, all right.
Okay. So this is where we are. All right. So we've seen the figures, right? We've seen the figures here, and I simply use the formulas to, please, can you hear me clearly?
Personally, I can hear you. I believe they can also hear.
Okay, okay, good. So I simply use the formula to get the figures here. So I'm going to just delete these ones. Okay. So I'm simply going to delete. And let's all do it together. So here, sorry, not this one. I'm simply going to delete from here. Okay, using the same simple formula that we've learned before. So you see, this is supposed to give x times y, right? So we're just simply going to multiply the figures. So we're going to start with equals x. X is B5. For us to look to get the content of this cell, we're looking at B5. So equals B5 multiplied by y is B6. So B6. Sorry, B5 rather. B5 multiplied by B6 and then enter. So when you do that, the formula already computes the answer, and all you need to do to duplicate the same for the rest of the cells is bring your cursor here and drag it. Okay, and then, sorry, this is out of it. This is the total here. Okay, so drag it and you see if you cross check with what you have here, you already have the same figure, and same goes for x squared. So this is the field or the cell we're looking at. So 78 squared. So we're looking at equals B. All right, so this is B5. B5. And you can simply do the same thing, multiply by B5. Okay, it gives you that figure and you simply drag, right? And then y squared, that gives us the cell we're looking at is B6. Okay, so B6 multiplied by B6. Okay, and you simply drag. And then to get the total, here we should have the total. So all you simply have to do is pull it all together. You use your summation, right? Pull it all together, your summation. Put it all together, your summation. Okay, so if you check or cross-check with what we have here, you can see the figures are the same. So it's simply for you to know how to put these simple formulas, and you're good to go. All right, so I would leave this will be your assignment. Figure out, I mean, you can do your Google search or figure out how you would get would use the formula to get the final figures. So that would be an assignment for you all. And if you have any questions, feel free to also reach out to the admin and would respond to that. So yeah, so that's it. Obong, please, over to you now. Obong, are you there?
Okay, I'm here. Okay, thank you, Edith.
Okay, yeah.
Okay, that's it. Let me mention here, I do appreciate if someone gives any question. If you have any question to ask, you can let me know. And I believe this is the last, I think this is the last part of the course. So if you have any question, I am the floor is open for questions from any part. I know we were rushing to finish, but if you can have any question regarding what we have done so far, from the start till this particular time, you can let us know now, or you can let us know later. But for now, I just want to see if someone can drop a question so that we tackle it now together.
All right, any questions? Please feel free to ask while we bring this to a close. Any questions for what we've done so far? Any questions? You can unmute and speak, or you put it in the chat room. Okay, while we are at that, I remember back in school, most of us students would run away from mathematics. I mean, it was evident from the 2 classes on mathematics we've had so far. I mean, before now, we used to have quite a good number of students in class, but when it comes to maths, and some people have phobia for mathematics. But then, I mean, we cannot, okay, Boma, please, Abiodun wants to speak, please unmute him. So, but then in life, we cannot run away from mathematics and its applications, right? So it's good, we also give time to study maths. And for those who are new to Excel, I believe you've been able to learn 1 or 2 things from what we've done today in Excel. And come the second semester, we'll go more deeper. It was just simple formulas that we used today, but there are complex formulas or very detailed formulas as to how you go about these things. Okay. All right. So yeah, Abiodun, you wanted to speak. Can you try and unmute now? I guess you've been. Abiodun. You can unmute now and speak.
Thank you very much. Yeah, it's been a long day because this course exactly. Well, my question is that considering the how to use Excel, is there any existing protocol, like if I want to use Excel now, is there any existing protocol to follow before I can get to that aspect of doing statistics on Excel, or it has already been fixed to the Excel to go directly to the protocol and how to do those exercises, like you don't get.
Okay, Ukoba, would you like to go, or I should answer that?
I don't understand about the protocols you're talking about. Is
All I mean is that
like the standard formula embedded in Excel. Am I correct, Abiodun?
yes.
Okay, I'll answer that.
Or
yeah, go
I
ahead.
want to speak. Yeah. The thing is that considering how to do it that the formula have already been inside to the Excel already. You can just be picking how to do it, or is there any existing protocol to follow before we can get to that aspect?
Okay, I have a question now. Yeah, good. I have said earlier that the issue of multiplying it out seems to me a manual method too, even though you are not the one to write with Biro, because in that case you are calculating as if you are using calculator. Good. Apart from that, I said there are functions. There are analytics functions in Excel. Excel is very large. Good. There are statistics functions in Excel that take care of so many parts of statistics. For example, like correlation, there is a part in correlation that you will just click, it give you answer. You do not multiply anything. You don't even know formula. The only thing is that for sure, the formula Excel knows is what we put down, because the answer will be exactly the thing we calculate out. So there are functions in Excel that work with. So you don't need to multiply this time this time this. No. The only thing you need to do is to code the data inside Excel. For example, now, like the example we've done here, you just need to go to Excel and code X, write Y, then put down the values of X, put the values of Y. Go there and click correlation. In short, you can just write equal to COR. Just write, once you click in those, all the values, X and Y, just look at one part and write COR. You see what will pop up. Yes, you see COR is correlation. If you bracket, it will tell you that you should put the regions that contain the data. You see space. So we just highlight data, highlight them, close the bracket and enter. The data will come out as answer. So there are functions for this analysis. I hope I've answered the question.
Thank you very much, Kobong. Yes, Abiodun, I guess that answers your questions. Of course, there are functions and embedded formulas already. And what we just did today is just, you know, very simplified formulas, but this is just first semester. So second semester, when we go into details, then you'd be seeing those functions in action. All right. Okay. Can we get was that on how to code statistics with Excel instead of, okay. Yes, this, for the sake of today's class.
You said whether you can get the sheets. Let me just answer this one. You said
okay,
whether we get a sheet on how to code statistics with Excel instead of manual method. We have just talked about that. That there is a way. There are mathematical functions that you will not even see in your eyes in Excel, but they are this thing. Those functions can be used to solve this thing. For example, we have mean, we have median, we have quartiles, we have standard deviation, we have variance. So they are there in Excel. So I have just talked about correlation now, that you just write equal to, instead of writing formula, just write equal to COR. Before you finish writing COR, the Excel will pop up the options which you can select from. So you see correlation, you pick. Now, once you see correlation now, it will ask you which data set you are using. So you must have code the data set into Excel before you start analysis. So in that case, there are functions in Excel that you use to run analysis. So many analyses. In short, everything you talk today can be analyzed with Excel. Okay.
And yes, and then what I would say to you, Abiodun, is Google is there, right? The internet is there. So for you and every other person on the call, make Google your friend. There are so many things that we may not cover in this class, or we may not have covered in this class, but go straight to Google or YouTube. I mean, it's very, they're all there. There was a time I downloaded a whole lot of, rather I saved a whole lot of videos on Excel, statistics, probability, and all. I got that from YouTube. So just type on YouTube and you'd get whatever it is you want, and you'd also learn from there, right? We may not be able to cover everything in class, but that's why learning is continuous and this study is continuous. So you have your time to check on YouTube and get yourself, excuse me, get yourself acquainted with these things as we wrap up for the day. Okay, so do we have any other question? Any other question before we bring this to a beautiful close today? Okay. Okay. Anyways, I guess we do not have more questions, right? So thank you so much, Mr. Kobong. It's been wonderful having you in class and having you take us through these studies. And thank you for the way you've delivered it, and it was quite self-explanatory, as it were. So thank you very much, and have a wonderful, wonderful weekend ahead of you. Right, and to every other person in class, thank you for being with us through to the end. Do have a wonderful, wonderful weekend ahead of you. Stay happy, stay blessed, until we meet again in the next class. Thank you.